I mean, I guess.
Check.
Hello?
Okay, good morning. Can you all see the screen? Should we put the lights down a little bit, maybe on the screen? Or is it good? Yeah? Okay. So welcome to the workshop. It's going to be quite hands-on. So I was wondering how many people have laptops and are kind of ready to follow on? Okay. Yeah. Okay, so maybe I'll do it live as well. And if you want to follow along, that'd be great, and do it yourself, that'd be good. So the topic of the talk is to look into what an L2 transaction is in the context of Arbitrum. So there are a range of different L2s, but the one we'll use today is Arbitrum. And L2 transactions will differ between those, but some of the concepts will be passed between them. So yes, there's some differences, some similarities. We'll go into some of those, and I'll first give a bit of an introduction about what a rollup is, and that's what I mean by L2 in this context. And then we'll go into the workshop itself. Okay, so at a very high level, a rollup is a sidechain, just another blockchain, but it's connected to some sort of base chain by a validating bridge. And if you want to read more about this, there's a paper by Paddy who sat in the back of the room over there. So you can get more information there. And this is a kind of rough overview of how it works. So you've got one blockchain at the top, which is the rollup. You've got the main blockchain at the bottom, which in this case would be Ethereum. And they're both progressing via state transitions. New blocks are being made. There's a bridge contract on the base chain on Ethereum, and periodically an operator will take the state of the rollup chain, and they'll paste it into that bridge contract. That once it's in that bridge contract, it can be checked. So in an optimistic rollup case, there's a fraud proofs that are used for checking that state. And in the case of a ZK rollup, it's just a ZK proof. But the other crucial thing is that green blob that I've put inside the bridge contract, and that's data that's associated with the state transition. So you on the rollup, you need a minimum amount of data to be able to recompute the state transitions that are occurring on the rollup. So in the case of optimistic rollups, that's going to be the transaction data itself. And yeah, it just continues in the same way. And this would be the case where some data is put on chain, the fraud proof is checked, and it's found to be invalid. Yeah. So this is a kind of rough life cycle of a L2 transaction. So a user would create a transaction, they'd submit it to a sequencer, who would then be collecting these transactions into a batch. When the sequencer has got enough transactions, they'll compress this batch using some standard compression algorithm. In Arbitrum's case, this is Brotli. And then they submit the batch to Ethereum. So this green blob is that batch there. Yeah, and another kind of difference between L1 and L2 transactions is gas. So as I've mentioned, L2 transactions need to be submitted at some point to the L1, and someone's got to pay for that. So eventually that's going to be the user. And that cost is associated with the call data that is required, that is consumed by the transaction on L1, and is priced at the price of L1 gas. Then there's L2 gas, which is basically the same as L1 gas, the same gas that you know on Ethereum, but it's at the price of L2, right? So this is just the execution of the transaction that's occurring on L2. So you pay first to put the transaction on L1, and then to execute it on L2. So there's these two different costs, and we'll kind of go into that in this workshop. Yeah, so this is the URL. So if you go to this GitHub repo, and you can start following down the set of instructions. So there's a set of prerequisites that include tools like Foundry, JQ, and Brotli itself. And you can start following the steps yourself, or you can watch me do it as I go. Yeah. Okay. Yeah, so I've included some useful links at the top. There's some RPCs there to connect to both Arbitrum and to Ethereum. And just some other stuff, some general information if you want to read more about like L1 and L2 gas and some of the ways in which Arbitrum works that are relevant to this talk. Yeah, so these are the prerequisites. Git's just there so that you can clone this repo itself. We've got curl for making some requests, Foundry for using cast. Cast is a kind of tool for helping you format ABI style functions for calling the JSON RPC. JQ just for formatting some JSON, and Brotli, which is the compression algorithm that's used in Arbitrum. Yeah. So there's a quick setup stage. I've already done this. I'll paste this in. Yeah, just check those are there. Okay, so the first step is we're going to send a transaction on L2. So I've already sent a transaction, which you can use if you want in your example, or feel free to use your own Metamask, connect to Arbitrum, and send a transaction on mainnet. At the moment, they're reasonably cheap, I think, so it should cost you only a few cents to do that if you want to. But this transaction hash, if we look at it on on Arbiscan. This is a USDC transfer, basically. So this is just transferring some tokens. And this is what we'll look into today. Yeah. So I'll set that environment variable. And also feel free to, like, if you've got any questions at any stages as I'm walking through this, just stop me, put your hand up. We don't have to get through all of this today, so just, let's talk about it. And if you've got questions, just put your hand up at any time. Yeah. So first we'll kind of grab a transaction receipt for that. And there's two interesting things in this transaction receipt that you might not be used to when looking at L2 compared with L1 transactions. So there's this L1 block number, which is the block number that the L2 sees of L1. So it's a kind of like the L1 is it's reading the state from the L1 occasionally, and one of those bits of state is the L1 block number. You can access this as part of the Arbitrum EVM. And then the other thing is this gas that it used for L1, and that's what we're going to look into. So this is the amount of gas that was spent to send this transaction and get it recorded on L1. Yeah. So we're going to store that in a variable. Oh, yeah. Okay. And I'll just echo that out so you can see like roughly what it is. So it's like 236,000 gas. So that seems like a lot when you think about just what it's doing. It's storing just a bit of data on the L1. But the reason why it seems like a lot is because this is in units of L2 gas. So this has been scaled for what it would be if it was on L2. And that's just to make the accounting a little bit easier inside of Arbitrum. So this amount, we need to find out what the ratio between the L2 gas and the L1 gas was at the time this transaction was sent, to then try and really figure out how much L1 gas was used. And from there, we can start to figure out as well, like how many bytes of data it might have consumed. Yeah. So I'll store some of these variables as well. Okay, yeah. So as I mentioned, we need to find out this ratio of L2 to L1 gas. So the rollup is estimating at any point in time what it thinks the L1 gas price is. And it's a little bit more complicated than just reading the L1 base fee, because there's a time lag between when the sequencer processes a transaction and when it submits it onto the L1. So it does some kind of estimating, and it moves its price up and down depending on how accurate it's been in the past, to try and make sure that it keeps even. And so there's this L1 get L1 base fee function, which is what is really used by the Arbitrum virtual machine by Arbitrum, sorry, to figure out what L1 gas prices it should charge. Yeah. And there's a bit more docs here if you're interested in reading about like exactly how that works. Yeah. And maybe we should go a bit more into that because I realize we're running quite quickly on time. Because I guess I thought everybody would be following along and there'd be lots of problems, but I'm a skilled pro at this, so it's going quite quickly. Yeah, so one interesting thing that happens with that estimation is that because the sequencer is having to try and figure out what the price will be when it submits to L2, it's kind of it ends up wanting to overcharge to not get out of pocket itself. So Arbitrum has a slightly different mechanism there, where the sequencer is rewarded later for exactly how much they spent. And there's a kind of a pool that sits on L2, and the pool starts quite full, and then the difference between what it was awarded and what it estimated in the first place is then reduced from the pool or added to the pool if it overcharged. And then this difference between what the pool target should be and what it actually is taken as a factor into the future estimate of what the L1 gas price should be. So the sequencer never ends up out of pocket. They always get exactly what they paid. But there is some mild fluctuation between what users pay now and what users pay in the future. So some users now might receive slightly less than what they get a slightly better gas price than what they expected. Some might get a slightly worse one. But overall, it's quite close to the average, quite close to what you should be getting. Yeah. Okay. So we'll call that precompile at the block heights. So that for this we need an archive node, and we're going to call the precompile at the block height when this transaction was sent on L2, and then we'll see what the estimate was at that time. So, yeah, absolutely, yeah. So you want to know what the estimate was at the time that the transaction was sent. So you need to know what the state of the node was at that time, and for that you need an archive node. A full node wouldn't be able to do this. Yeah. Say again? Exactly. Yeah, I think full nodes do keep some recent historical states. I can't remember exactly how, but probably not a week's worth. Yeah. So to do this kind of thing that we're doing now, you would need an archive node. But this isn't something that you might normally want to do. This is just kind of like, let's go look at some of the analytics. It's not part of like, you don't need it to send transactions or things like that. And there are ways to get estimates for what these values are before you send your transaction as well. So you know what you're going to spend. You don't have to wait and inspect it afterwards if you want to. Yeah. Yeah. I think there was someone. Uh-huh. Yeah. Okay. Thanks. Yeah. It's not a snapshot. It's just, well, yeah, okay. You need to know what the state was at that time, because this is stored in state, this L1 base fee estimate. So at a different block height, the L1 base fee estimate will be different, and we want to know what it was when this transaction was sent. Yeah. 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 So the sequencer has to pay some cost to put this data on chain, and it wants to get refunded for that. So this estimate is in the system. It's under, like, you might say, it's under consensus of the L2, and the sequencer is forced to use this value in its estimate. Yeah. Well, the currencies are the same, so it's both ETH is the unit of accounts, yeah, on both of them, yeah. But the gas prices are different and they're moving, and this is just a way to try and estimate that movement of gas on L1. Yeah. Okay. Okay, so let's make this call. Yeah, so this was an estimate of the base fee at the time, the L1 base fee estimate, which is about 8 gwei, it looks like. So that's what it thinks it was at the time. And we'll store that in a variable. So as I mentioned, we want to work out this ratio so that we can scale the L1 gas used from L2 gas units into L1 gas units, so that it starts to make sense to us again. So we also need to know what the L2 base fee was at that time. And this we can do by just fetching the block at that height and looking at the base fee in it, which is 0.1 Gwei. So Arbitrum has like a minimum L2 gas price, which is 0.1 Gwei. If congestion happens, then it will go above that, but generally it just sits here if it's not being used heavily at the time. Okay, so we'll store that as well. And now that we have these two ratios, these two gas prices, we can use them to calculate the ratio. So, have I stored this already? Yeah, that was above. Yeah. Oops. So there's the actual amount of L1 gas that we used at the time, which is a bit more what we kind of expected. And if we divide, why did we expect that? No, a bit more like, not more than. It's like what we expect. Yeah. Yes. Yeah, it's a really great question. So we do compression over a full batch rather than individual transactions, which does leave you with this problem, right? How do I know what my transaction, how many bytes it will use in the compressed batch rather than in the other amounts? So what we do is it's very hard to figure that out and do it fairly because it also depends on ordering and things like this. So what we do is we compress your individual transaction when we give you an estimate for it. And so if your individual transaction is more compressible, you'll get a better estimate for it, and you'll be charged less. But that still isn't quite the perfect scenario, but that's the kind of like halfway house that we've arrived at. Yeah. Okay, and so each unit of each byte of data on L1 consumes around consumes 16 gas if it's a non-zero byte. So as an estimate, we can say that this consumed around like 180 bytes of data. So we can then actually go and take a look and see if that's kind of what it did consume. So to do that, we'll RLP encode the transaction. Oh. Which has got, I've got an error in my script there, I think. This AABCC doesn't look right. Yeah, I was doing a bit of debugging. Yeah. So this script, what it does is at a high level is just it requests transaction receipts, takes the bits out of it which are important for an actual transaction. RLP encodes it and just spits out the result with the 02 prefix, which is type 2 transaction. So if we do that again, not sure why that's. Oh yeah, thanks. There we go. Thanks, Rigisha. Okay, and if we count those bytes, then we see it's about the same. Yeah. So we spoke before about, yep. Say that again. Sorry, I couldn't quite hear. Yep. So RLP is just the format of the transaction that Ethereum accepts. And then we'll include RLP encoded transactions into a big batch, and the batch will then be compressed with a compression algorithm. So RLP isn't compression, it's just serialization.
So I guess if you wanted to access this for fraud proof, is there a way?
You don't need to. Yeah, because what runs under the state transition is the full decompression. So when you run the fraud proof, you're bisecting on the parts of the state transition. So if the decompression is within that state transition, then yeah, you'll be able to decompress. You don't need an implementation of the decompression on L1. You need it on L2, and you need to include it in the state transition. Yeah. Yeah, so let's try and explore the batch. There's a function on another one of the precompiles that you can find on Arbitrum to find the batch containing a specific block, which is this one. So we stored the block number earlier, and we'll use that to look up the batch. These precompiles, by the way, they're kind of like the way in which Arbitrum customizes itself compared to Ethereum. So it needs to do some special things like this, and they've been added as precompiles. So they can be found at like different addresses that you can find at the top of the files. Yeah, so we use cast again. This is a little bit longer. Wait a minute. Oh yeah, there it is. So 974 was the batch number. I don't know why it printed some rubbish, but oh yeah, it's because I copied the. There we go. Yeah, it takes a little bit longer, that one, because we're doing. Oh no, that one's not the longer one. Okay, this one might be a bit longer. So given the batch number, we need to find the transaction that submitted it, and we need to look at the call data that was in that transaction, because that will be the batch. So we need to find the transaction. And we do this just by looking up the logs that emitted this specific batch number. Yeah. So this is the transaction ID. So if we go to Etherscan, this is an L1 transaction ID. This is the batch itself. And if we scroll down and look at, oh, whoops. So it called this function, add sequencer L2 batch from origin. And if we look at the original, this is all the batch data. So it's a large amount of data being submitted in one go. Yeah. Yeah, we can even look at this function in the code. So this is the contract, which is called the sequencer inbox. And it's where this sequencer submits these batches. And this is the batch data itself. So we're going to try and grab that data and decode it. The way that variable size arguments in the EVM are encoded is at the end, and there's a placeholder for them inserted at this point. So we'll find this data at the end of the arguments list, and given these are all fixed size arguments, we can know the exact position in them in that input, which is well, first we'll download it actually, yeah, here, which is 458 is the position. And we'll put it into a file. So if we open, so this is the raw batch data that we downloaded. Raw is compressed, exactly, yeah. So yeah, this is pulled straight out of the call data, and this is what the sequencer inputted, so it's compressed.
So the data you show is the compressed data?
Yes, exactly, exactly. Mm-hmm. Great question, and we'll explore that in step 5. Yeah. Yeah. So if we open the file, we can see that it begins with this 00 at the start, and this is not part of the compression. This is just a type of the data. So there are some different instantiations of Arbitrum. One is called Arbitrum 1, and another is called Arbitrum Nova. And they handle data in different ways. So Arbitrum 1 does this compression. It stores all the data on Ethereum. Arbitrum Nova doesn't. It stores its data with an external party. Those external parties sign that they've received it, and they put that signature along with like commitments to that data on chain. And this 00 here just tells us that the type of this data is rollup data. It's Arbitrum 1 data. So we want to remove that before we do the compression. Do the decompression, sorry. So we take those off and put it into another file. And then we just remove those front two zeros. And then this is the commands to decompress the batch. So first, I'm going to convert it from hex into binary. Then I'm going to use Brotli decompression. And then I'm going to convert it back into hex and put it in a file. Yeah. And it outputs this warning because there's some 0 bytes at the end which aren't actually relevant to the compression, but get added because of 256 byte words. Okay. So if we look at that, this is the actual batch data, and we can look at the size differences now between the compressed and the decompressed. Make that a bit bigger. So we've got this one, which is the wait, what was it? Which one? Compressed, which is 198 bytes. And then we've got the decompressed one, which is 715. So you can see the difference in the ratio there and the effectiveness of the compression. Yeah. Yes. Exactly. Yeah. If there's shared structure between different transactions, then they're going to be included into this compression and improve it. Yeah. This is a bit of a the compression isn't actually this good because if we look at this batch data, it includes a lot of zeros, and zeros are charged at a different amount in gas in the EVM. They're charged at 4 bytes, 4 gas per byte rather than 16 for non-zero bytes. And the compressed batch will be almost no zeros in it. It'll be much more like a tenth of them are zeros, right? Rather than a 16th, sorry. Yeah. Yeah. So it's not quite as good as it's showing here, but it's still quite good. You can work it out by like doing some more complex analysis, but we won't do that here. Yeah, so we've compared those. And then the last thing to do is that our transaction should be in that uncompressed batch. So we'll go and try and find that. So if we echo the RLP, I think I had it in raw maybe. Let's see where I had it. Oh. Yeah, I did have it in RLP. Oh, a TLP I've written. Yeah, so this is our transaction. If we go into the batch, and there it is. So along with a load of other transactions. Yeah, and that's basically it for the workshop. So if you've got any more questions, yeah. Yeah, you can do that yourself as a developer. So on Arbitrum, there's a registry where you can register address against an index, and then you can substitute them, and Arbitrum will know that you've done that, and it will then switch them back out when it comes to execute. And in that way, the sequencer will charge you less for your gas. Yeah. Yeah, because when you're compressing the addresses in a batch, then it does a lot of that for you anyway. Like so, the two, yeah, it's one was like a legacy system where we would allow users to do this themselves, and now like the whole holistic batch way achieves a better result. Yeah. Do you have a second question? Yeah. Can everybody hear the questions, by the way, or should I repeat them? Yeah. Sorry. Yeah.
So is there an certification effort taking place for
No, there's not. So like Optimism used zlib, I think, and we went for Brotli. The reason was because we did some analysis of different compression algorithms, and we found that Brotli performed best. And I guess they did a similar sort of thing and chose zlib for their own reasons. Yeah, I don't know how important it is to standardize this specific part of the rollups, because it's something that users shouldn't really be interacting with generally. And I think that's the most important part to standardize. But yeah, it would be interesting to see why they chose that as well. Yeah. Sorry, I didn't repeat the question. He asked if there would be if there's any efforts to standardize this compression algorithm. Yeah. Across different L2s. Yeah.
You mentioned earlier that is a registry. Is it that they can use it like stable compression?
Yes. Yeah. So there's an address registry that you can use. You register an address against an index, and then that will be used when upon execution. You substitute your indexes into your transaction, and then they will be desubstituted from the registry upon execution to reduce the amount of call data that even goes into the batch itself. Yeah. It should be. So we used to have it in our docs. We've just recently revamped them, and I'm struggling to find it. But we did used to have it there. Do you know where it might be, Jagish or Fred? Arbor-address registry. So we've got Arbor-address table here, which is the. Yeah, so this is like a bit of documentation, but I'm sure we had some more documentation about actually how to use this contract in precompile, didn't we? Okay, maybe we can do this afterwards as well. Yeah, yeah.
So this was like legacy behavior and operations.
Yeah, so the compression, the Brotli compression was part of Nitro. Exactly. Yeah. It was one of the major parts that reduced the cost. Previously, we didn't compress at them. Yeah. Yeah. Yeah.
I was curious why the hard-coded minimum base fee.
Yeah. So the question was why the hard-coded minimum base fee? I think that's partly just to avoid like us getting loads of state bloat early on for very cheap price. Given that we may expect users to come on board onto the platform and the gas price not to always sit there, it would be good to not the future not to be burdened by that kind of legacy behavior. Yeah. 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 Yeah, so the question was the execution occurs on layer 2. So what's happening on layer 1? What are we putting there? Yeah, you just store the data such that there's enough data there so that anyone who's observing Ethereum can recompute the same state transitions that are occurring on L2, and that's important so that anybody can take part in a fraud-proof game. Yeah. Yeah.
Yes, lighting contract pulled up earlier. Did you have to simply putting that into the
Yeah, we have two ways of doing it. So I'll open up that contract again. The question was in the contract, do you need to emit all of the data, the batch data in an event, or can it just be in the call data of the transaction? Yeah. So we have two functions for that. One is submitting it from origin, and in this case, we know that it's being sent from the transaction origin, and therefore we know that the call data is going to look like this. So if we know that, then the L2 can reliably grab data out of the call data. If the sequencer is going via some other contract, or it's not coming from the transaction origin, then we emit the full batch data in an event. So in production, this is here if it were needed, but in production it's way more expensive, so it's never used.
Sorry, why do you not need that in the first case?
Where do we not need what? Sorry.
What? Sorry, I missed what you said. Why do you not need to submit those?
Yeah, so to clarify on what we're doing here, we're emitting a sequence number. And what the L2 node will do is it will say, okay, I've got a new sequence number. I'll go look up the transaction related to that sequence number. I'll look inside the call data. I'll find the batch. Basically the same process as we've just done. And all of that, doing all of that is part of that state transition function. So it's all, yeah. Yeah.
So just to verify my understanding, execution happens on layer 2, right?
Yes, execution happens on layer 2, yeah.
State is on layer 2.
And state is on layer 2 as well, yes.
So as the transaction is full data on layer 1, I assume that in this contract something is being executed. Is this the actual transaction or just the state?
Sorry, I missed a bit. You said there was.
So let's say that I send a transaction that I send some tokens to you. Okay?
Yep.
Does this happen on layer 1?
No, so the question is does the execution also take place on layer 1 as well as on layer 2? And no, it doesn't. We just put enough data such that anyone who's reading the Ethereum can then go away and recompute themselves what would have happened and take part in this fraud-proof game.
So in that case, if somebody monitors that on Ethereum one day, he has to replay a lot of blocks.
Correct.
Because the state is not there, but that's in one block, right?
Exactly. Yeah. Yeah. You need so yeah. If you want to know what the state of the L2 chain is, you need to replay the history of the chain in the same way that you would replay the history of L1 to figure out what the state of L1 is.
Is there a way to ask on L1, can I have blocks of RB2 that have some transactions for this address? Or I have to pass all your contract transactions to that by some.
Yeah, so the question is can I find out states about a specific address without recomputing the full state on L2? And the answer is no. So the state only exists on L2, and that's only where you can make questions about the state. Yeah. Yeah.
I have a question about that smoothing buffer. When you have filling the height
Yeah.
of that buffer that's actually the sequence of events. So would it be a lot of data on algorithms when you actually pass it about time sensitive? You can wait for that buffer to be above the target values and you will get.
Yeah, so the question is, can you sort of game the system, take advantage of this minor fluctuations in L2 gas price to try and achieve a better price for yourself? And the answer is yes. Yeah, you can. Yeah.
How do you achieve better gas price scalability? Because at the end, what we do on layer one is just some cold data, and based on that, we can decide like we pay some gas, okay? But on layer two, this actually running. It's the same as running them on layer one, but with cheaper gas.
Yeah, so I think that's that. The question there that comes down to a little bit around your security assumptions. So in order for the state to, in order for you to be confident of Ethereum state, you want a wide range of people to run full nodes, such that if an invalid state transition occurs, a large number of people can get together and form consensus that that was an invalid state transition. That should be a rejected fork, and we should ignore it. But with rollup, there's a slightly different safety assumption, which is that if any single one person notices that there's an invalid state transition, then that one person can enforce that the state transition is corrected. So you don't need a large number of people necessarily. It's a kind of one of n security assumption rather than like an n of m. And so this means that maybe you can afford to have less people actually running the L2 nodes. Yeah. And so have maybe slightly more beefy machines. Yeah. Yes.
I know this is a little bit outside of the commercial, but directly related. I've heard a lot of information about scenarios that said like, you make a scenario what would happen. Say someone actually, which has never happened before, right? Actually submits that topic. What would be and what would play out of it?
Yeah. Yeah, we can go into it. Yeah, sure. So the question is like how in practice do fraud proofs work?
Especially what happens afterwards.
Okay, yeah. So two parties take place in a fraud-proof game to figure out which of them has chosen the correct state, and then one of them wins, which is what you're asking about. And at that point, that state is the losing state is rejected. More people can challenge the winning state if they want to, but the losing state is rejected. Whoever chose to take part to defend that side of the state will lose some stake because you have to put at stake to defend a state. And if no one comes to challenge the winning state, then that will be accepted as the correct state, and you'll go on from there. No, the L2 doesn't. The L2. So if you're running an L2 node, you've got your. If you think about a fork occurring on Ethereum, you've got some people that choose different rules for their node. That doesn't mean that you need to stop running your node with what you see as the correct rules. And the same kind of happens on L2. I can run my node and I can see which of those two is going to win the challenge because only one of them is correct, and I know which one of them is correct. So I can continue to accept transactions, validate them, and we can continue to process them in that time. What you can't do during that period is withdraw funds from the system. So withdrawals are paused whilst this fraud-proof game is taking place because Ethereum itself doesn't know which of those two states is going to be correct. So the funds stay in the system while it's happening, but we can still progress the state as an external viewer. Yeah.
or like, because you have to start count them, apply state transition. Where's that from?
So I'm not sure I fully understand the question. Yeah.
If someone challenges, we have two different states.
Yep.
And where do we start? Previous state?
Yeah. So the question is like if two states are in violation of each other, there's people defending either side. What are we actually challenging? What's the state transition that we're challenging? Is it from the previous state to the current state, or is it further back? And the answer is it's just the previous assertion. Yeah.
This takes place in the contract, right? But the whole compression of the contract, you have all the things in place in the.
So the question is, do the fraud proofs take place in the Solidity contract? And yes, they do. But the way they work is that there is a bisection game that the two parties play. We don't want to execute the full state transition again. So instead, we try to decide which part of the state transition we disagree on. So we take the state transition, we bisect it into many parts, and we allow the other person to choose which part they disagree with and which part they agree with. And so you're reducing the size of the state transition, always keeping a point that you both agree on, and always keeping a point that you both disagree on, and making that smaller and smaller and smaller until you get down to a single opcode, and then you execute that single opcode. Yeah. Yes.
So what if two parties disagree on multiple transaction states or points? Would they have to submit separate proofs on different
So is the question that within a single state transition they disagree about multiple things, or is it that there are multiple people disagreeing about one? Okay, so if there's two parties but they disagree about multiple things, then it'll just be the first disagreement that matters, because that's all you need to slash the person out of the system and remove their state from the system. Yeah. Yes.
Yeah. So if I have partial transactions, I have a frauding transaction and a transaction that's illegal. If someone opposes that state transition and we revert it, does the legal parties get replay again?
So I think your question, is what happens if someone includes an invalid transaction in the batch, or?
Yeah.
So the Arbitrum virtual machine will know what to do if someone gives in an invalid transaction. It will ignore it, basically. So you can then choose to run a different Arbitrum virtual machine that would do something weird with that, and then we would end up at different states, and we would like challenge each other over the result of that. But just including an invalid transaction in the batch isn't enough to like confuse an honest validator that something weird has happened or that they've got the wrong state or anything like that. There are rules about what to do for every byte that you see in that batch. Yeah. I think, sorry, there's one at the back first, sorry. How long do we have left? These are great questions, though. Yeah.
About not being able to draw during challenge. Couldn't you just, with a very cheap attack, by like causing challenge just like, for a long time, not to be able to.
So the question is, sorry, you did. Yeah. So the question is, given that during a fraud-proof game, withdrawals are paused, isn't there an attack you can do on the system to delay and cause problems for everyone else by just creating a challenge? And what is the cost of that, of creating that challenge? And the answer is dependent upon how high the stake is set. So that's, yeah, if you have a very high amount of stake, then it becomes very costly for you to cause this delay.
I would choose a low amount.
Pardon?
I would then choose a low.
The amount of stake is set by the system. So in order for you to take part in a challenge, you need to put up a certain amount of stake. Yeah.
You know what that is right now?
So at the moment, the validator list is whitelisted. So it's not open to the public. So whatever value in there is not really meaningful. But we're working quite hard on trying to make that open. And when it is open, I can say that it will be quite expensive. Yeah. Yes.
I run node and I know that sequencer. Commit a prompt. Now I challenge it. Now I will become. I win this challenge. Now the sequence on chain is broken. Malicious sequencer had a bug or was malicious. I could prove that I was correct.
So there's a separate. So the question is what if the sequencer is malicious, tries to cause an invalid state transition? Is that the?
Yes. Someone challenges.
Right. And what happens when someone challenges? So there's a separation in the system between sequencing transactions and executing those transactions to create a state, to update state. So the sequencer has no power over what state will be updated, what the state will be based on what it puts there. The node software does. So if the sequencer puts rubbish there, the node software, like honest node software, will recognize it as rubbish. If the sequencer puts valid stuff there, then they will process it as valid stuff. But the sequencer is all it's doing is putting data onto the chain. They don't enforce in any way what the state should be that's a result of that data. Those are the validator nodes that decide that. Yeah. So given just some data that arrives, people running validator nodes need to decide what the result of that data would be. Yeah. Does that kind of answer the question?
Yes. So the only thing that the sequencer can do is put invalid data, malformed data, like unsigned data.
Yeah.
That can do.
Yeah. And the nodes will know what to do when they see that. So there'll be strict rules about everything that the batch contains. Yeah.
The sequencer can add data as well and actually kind of manipulate that order.
Exactly. So the question is like, what powers does the sequencer have in the system? And the sequencer can choose ordering of things inside that batch, but they can't manipulate what the output of those transactions will be. Yeah. So you don't trust them in any way for the security of the system. The sequencer is necessary for liveness of the system to get transactions moving. Fred's like waving his hand over there. Like,
follow up with that. And are there any checks on the sequencer by the validators? Like you mentioned, validators will recognize the rubbish, but what can they do at that point?
Yeah. So at the moment there aren't, right? So at the moment we trust the sequencer to behave well. If they don't, then we won't be able to use the system properly. The funds will still be safe that are in there, and there's a secondary backup system which normal users can use. So you don't have to go via the sequencer if you don't want to. You don't get the benefits of compression, but you can send your transaction yourself, or you can find someone willing to compress stuff for you and put it into the system for you. But they won't. Fundamentally, the sequencer is the one who chooses the ordering, and you won't be able to do that. We have like a time period where if the sequencer is not actually doing its job at all, if it's not updating things, or it's not including these what we call delayed messages, which are user sent messages via the L1, then after a time period you can force those through regardless of the sequencer. So that's the kind of backstop if you need to exit the system and the sequencer is not allowing you to send transactions. Yeah. But it's not really the validators that are involved in that. It's more the users who say, okay, I don't like the system anymore. It's not working for me. And I want to just force my way out of it. Yeah. Yes.
I don't know if it doesn't make sense, but if we have the possibility of return state, what's the finality of transactions of
Yeah, so that comes back to your node software, right? So if you can see that this state is correct, then yeah. So the question was, it's like, how does finality work in the system, given that after a fraud proof, a certain state will be rejected? So the answer is, if you were following that invalid state, then you will basically see a reorg, probably quite a deep reorg. But if you were running honest software, you won't see any problems. Basically, you won't see any difference. There'll be no change. Yeah, but you can but that does bring into question what the finality of a transaction is in there. And as you pointed out, you could get this deep reorg. So it depends whether you're running software. It depends like whether you're running node software or not. You might want to wait just until that week period is up, all challenges are over, and then just be like, okay, now it's definitely fine. Yeah. Yeah. Any more questions? The question is there an easy API that I can use to see if the challenges are complete? And the answer is that you can look in the smart contracts. So the smart contracts are created and destroyed when challenges exist. So you can see in the smart contracts all the challenges that are taking place at any one time. Yes.
So, if you have an invalid state, you start building off of that with every not invalid.
Yes, it will.
How would you ever?
If you think that if your node software has a bug in it, or you've done something malicious with your node software, then you'll be following what will not be the canonical chain eventually, and so you'll see results that will never happen, or may happen in a different way. The transactions will still be replayed, so all the transactions are on L1. So anyone who wants to run honest software can know what the final state will be. But if you're running some sort of like mutated software or something like that, then yeah, after 1 week's time, you may find that all of that state that you thought existed didn't, and you're actually on this other chain.
My question is like, how do you get out of that situation? Where you're on that invalid state. I don't know exactly how to phrase it.
The question is like what? The question is what happens to me when that challenge ends and I realize that I was following the wrong chain? Is that the question?
Yeah, okay, so the challenge ending is sort of.
Yeah, the challenge ends. No one decides to dispute this state transition. Basically, everyone in the world is agreeing on this state transition at this point. If they didn't, and they would start challenging it. Okay, I've got to wrap up now. But thanks very much for the great questions. And yeah. Hey, I'll just take this off. Thank you very much.
Okay, Chris. Fancy. Are we? We know. Okay, cool. Are we good to start? Yes? Okay, cool. I don't know if this fits in 60 minutes, so we will try this now. Hi, I am Emily. I am the Truffle Developer Advocate. Today, we're going to be talking about building a dApp on Optimism, specifically talking about how to incorporate bridging into your Optimism dApps. Just want to give a brief disclaimer. I do not work for Optimism, nor do I represent their opinions. However, I really love the project. Truffle and Optimism have been doing a hot collab, and that is why I'm here today. So briefly touching on the agenda, I'm just going to give a crash course on L1s and L2s, assuming we have beginners in the audience. Touch a bit on bridges, go into Optimism contracts for bridging specifically. And then the best part of the demo, I guess a live demo, maybe with Devcon Bogotá Wi-Fi, building a dApp together. So let's start off. Optimistic rollups, here's a crash course. So for those of you who don't know, just brief introduction, right? What's a layer 1? What's a layer 2? Layer 1, Ethereum, Bitcoin, that base layer. Layer 2, that separate blockchain that's focused specifically on increasing transaction speed, scalability. And what's really interesting here as well is utilizing Ethereum for data availability. So specifically the point of posting transaction data and getting it from Ethereum. I do want to note one specific thing. You might wonder, layer 2 specifically are defined by deriving its security from Ethereum. So if you think about something like a sidechain, for example, they don't. So those are not qualified as a layer 2. So that is like basically the key caveat you need to think about. So why do I even care about this? Why am I here? Again, if you've been around in the space, you've probably heard blockchain trilemma. It's a pick 2 out of 3, decentralization, security, and scalability. For those of you who in the Ethereum community, I hope we have all agreed that decentralization and security is the most important thing, right? So what happens about scalability? Well, this is something we still really need to care about because scalability, right, affects gas costs. And gas costs is going to affect the adoption of Ethereum. So this is something we really need to think about. And who's here to help us? Layer 2s. Okay. Thank you. Right. So definition again of a layer 2 is to decrease L1 congestion by bundling up transactions and submitting that to Ethereum. Again, things to note, right? Gets its data availability from Ethereum, specifically deriving its security from Ethereum and helping us maintain that decentralized aspect. So next piece, we're going to talk about optimistic rollups because that's what we're focusing on today. I am not going to touch on zero knowledge. There are so many talks at Bogotá about zero knowledge, so talk to them, not me. But to briefly touch about optimistic rollups, rollups, again, pretty self-explanatory. You roll up a bunch of transactions and you submit it and post it once to the L1. Again, this comes in 2 primary flavors right now, optimistic rollups as well as zero knowledge. To touch upon optimistic rollups, what makes those different is they are optimistic, right? So when we submit these transactions to Ethereum, we just assume they are valid. And you might say, wait, that seems kind of bad, right? Well, actually, there's this thing called the challenge period. So essentially, during this challenge period, Anybody can come and say like, hey, I think this is wrong. And if they do that, they have to submit a fault proof. And basically the fault proof basically either validates, hey, actually it was correct, and then it gets submitted to the chain. Otherwise, no, actually, yeah, some shady person did something and this like transaction is incorrect. And so let's backtrack. So that's optimistic rollups. Again, the challenge period is the part we need to focus on here. Right now for mainnet, it is 7 days, which is kind of long. Which is kind of why people have started thinking about zero knowledge rollups, because that is something that you just post the validity proof for. Okay, so I think that's covered everything in optimistic rollups in hopefully less than 2 minutes, because that's what I planned for. So let's talk about bridges now. Again, bridges, I think pretty self-explanatory if you've ever walked on a bridge before, connecting to blockchain ecosystems. Things to note about bridges, right, again, is this transfer of assets and information. So a lot of times we talk about transferring ETH, tokens, but you can also transfer arbitrary data. The other piece is, we're moving towards a multi-chain world. Basically, the point of that, right, is to take in the pros of one chain to alleviate the cons. So when we're talking about L1s and L2s, we're talking about the pros of decentralization, security of Ethereum, while alleviating the cons by using an L2 chain for that scalability aspect. The important part with bridges is it allows us to call an L1 contract function from the L2 and vice versa. So if I'm on like optimism contract and I say, hey, Ethereum contract, I want to call your function, bridges say, okay, we can do that. The typical way of doing this right now is this idea of locking assets. So it kind of looks like user one will lock assets in a bridge contract. The equivalent amount of like token will be, I guess, created on the L2. And then when we want to put it back, all of that is burned off and then released for the person on the L1. Again, big disclaimer, there is no bridging standard that exists yet. Again, a lot of research has gotten into this. I think also probably one of the reasons bridges are a little bit unsafe, because it's totally a new frontier, right? So when we talk about unsafe or security, right, bridge hacks happen all the freaking time. I don't know, if you're on crypto Twitter, I'm like, okay, cool. I mean, as of August 2022, right, there is a study done, basically 69%. I don't know if that was like fake number, but 69% of attacks have been on bridge hacks. And then very recently, actually, like right before I was creating this presentation, BSC Bridge, rest in peace. But you did good for my presentation because I got to talk about you on the next slide. But anyways, why does this happen? Again, as I had mentioned in that previous section about how bridges are typically run, is it locks up liquidity. And that is like a prime centralized location for bridge hacks. So something people might also think about when creating bridges is the idea of decentralized bridges. I don't know too much about it, so I'm not going to go into it, but you can kind of think about like that is a consideration you need to take, and centralization is, again, a big part of why bridge hacks are so intense. So how do you fix this? Again, disclaimer, I am no security expert, but number one, learn from BSC. So for currently, the way these bridges identify and authenticate target and source blockchains is through its chain ID. And the BSC case specifically did not check the chain ID through the cross-chain message. And again, something to think about. So obviously, if you're building a bridge, maybe read up on all your predecessors and do everything they did, but better. Private keys, again, that's something we really care about. Different ways of handling it, hardware wallet, multi-key chain system, etc. And then I think something people don't necessarily always think about is there's always that web layer, right? So the way bridges are surfaced right now is often through a UI, right? We talk about hardening your smart contract. Maybe one way to also think about how you harden security is at that UI level. There's a lot more. I added a link of like some research that people were doing, but you could probably just Google and then like read every single page because it's intense, guys. So anyways, yes, like I said, bridging is hard. What are we doing here? We're actually going to go over Optimism's bridge contracts. They have already written a few contracts as well as provided an SDK for us to do this for a simple use case. Again, I think it's awesome because basically bridge contracts probably require a lot of security auditing. I am poor. I'm not a student anymore, but I'm poor. I can't do that. So Optimism kind of has provided that ability for us to incorporate bridging through battle-tested contracts as well as an SDK if you don't want to do any solidity at all. So let's actually walk through what Optimism has provided. So that first thing I talked about was transferring of data. So this is kind of the base level of what it looks like. There's two contracts called L1 cross-domain messenger, L2 cross-domain messenger. Again, these are pre-deployed by Optimism. So if you're bridging on Optimism, you will be interacting with these contracts. You can get their addresses from their GitHub repo. They will have one for each chain ID. So there's an address for Gurley Optimism, there's an address for Gurley, Ethereum mainnet, etc. Kind of diving into this deeper, the way this works is essentially I'm going to highlight probably the two most important functions in this interface. Specifically, the first one is send message. So that is what allows us to say, hey, I'm L1 contract, but I want to call contract function on L2. The way this works is, let's start over. I am Ethereum contract. I am calling L2 contract. That's the target address. So I'm going to input that in there. The second piece is call data, right? So if you don't know how basically Solidity calls functions right now, it's encoded into bytes, specifically by like the function string name as well as the inputs that go into it. So in order to call it on the L2, I have to encode that function name and inputs to be passed over to the L2 contract. And the gas limit actually is pretty complex. It seems simple to understand, but it's how much you're willing to pay. So I'm going to go into the math here. Specifically, posting from L1 to L2 requires gas on the L2 section, right? In order to do that, Optimism says, we will provide 1.92 million L2 gas for you for free. However, in the case, and this is pretty rare, assuming that like maybe you actually need to spend more gas than that, you actually would have to specify that ahead of time. And that gas is coming from your L1 gas at a 1:32 ratio. So in this specific example, right, suppose the transaction actually took 2 million gas on Optimism, you have 80,000 L2 gas you need to cover, which is equivalent to 2,500 L1 gas. I hope that made sense. If not, we can talk about it, and I will just say the same thing over until you understand it. On the other hand, we moved from L2 to L1. This is going to be more expensive because there's two transactions we're posting. Specifically, the L2 fee to initialize the transaction, and then the L1 fee to actually finalize it on the chain. So this is more expensive. L1 is significantly more expensive than L2, but that's because scalability. Wow. Okay, good. Next piece is cross-domain messenger sender. Okay, again, for those of you who don't know, when you call contract functions on a smart contract, message.sender is how you know the address that it's calling it, right? But for example, when we're thinking about bridging, right, say I'm like L1 contract calling L2 contract function, message.sender is actually gonna, surface the address of the L1 contract domain, cross-domain messenger contract, right? I don't know if I said that correctly, but you know what I mean, the pre-deployed Optimism one. So what do we want to know, actually? I want to know my address. I want to know the L1 contract address. The way this is implemented actually allows to say, okay, when I call X domain, blah, 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 I'm going to return my address, not the address of the deployed messenger contract. Again, the next piece here is transferring ETH and ERC20 tokens. This is probably the most common way of doing bridging, which is why Optimism has kind of put that behind an SDK. I'm not going to get into it because I only have 50 minutes. Thank you, Dev Bogotá or Devcon. But there is a really great Ethereum tutorial written by a person on there that actually steps through the contract step by step. So if you are interested in understanding how the token bridge works at a smart contract level, I suggest going there. If not, I will be diving into more of the part about using the SDK itself. I want to know as well, there are some things to know. You cannot bridge every ERC20. So the way the token standard bridge works is it identifies both the, let's say, ERC20 token address on the L1 and then a token address on the L2. However, there are many ways you can, I guess you could have the ERC20 token represented multiple times on the L2. So how does the Optimism standard bridge know which one to use? Well, that is specified specifically in this token list. So if you want to add to that token list, you have to create a PR so that the token bridge knows which contract to bridge between. And then two keywords here, deposit. So deposit means I'm depositing ETH going from L1 to L2. Withdraw is going to be withdrawing, so going from the L2 to the L1. Okay, so let's do the build portion. What are we building? So starting off, I think one of the most common use cases where you might want to embed a bridging UI is an NFT marketplace. So we're building one on Optimism, and I want to talk a lot about bridging because of the UX problem. So if you've interacted kind of with bridging right now, oftentimes it's a separate UI. So you go to another website or something, do the bridging, and then come back. We're smart here. We're at Devcon. We understand how to do that. Not necessarily the best UX for, I don't know, my mom. So what's the solution? Her name is Bridget, the bridge widget. Hopefully you understood that pun. If not, I will explain it to you many times until you understand it. But anyways, the point is to embed this kind of UI. It is just a component. So imagine if I took the time to put this on NPM, you could just NPM download into your app. I didn't do that because I don't have time. But anyways, this is kind of the UI of what it's going to look like. You can create, mint and list an NFT, mint your NFTs, see what you do. You can buy them. And specifically, one of the views is going to be that bridging component, which is what we care about today. So what you'll need is we're actually starting, this is where the Truffle collab comes in, guys. Okay, so Truffle has these thing called Truffle boxes, which essentially create, I guess, scaffold code or educational code to help you start your dApps quickly. I wanted to talk today specifically about the Optimism Bridge box because it is basically a empty project that configures a project ready to be deployed on Optimism, in addition to adding smart contracts that will do the transfer data portion, as well as writing a script that will demonstrate how to do the SDK. And so in part of the smart contract portion, what it does is it actually allows you to figure out how do I deploy across multiple chains in one go, right? I need to deploy on L1, L2, and then I call a function on L1, and then I call a function on L2. How do you do that? Truffle box. Right. Okay. What else will you need? We are going to be connecting to the Gurley testnet as well as the Optimism testnet because we are working with these deployed contracts. So you will need that information from Infura. You'll create a project separately to that because this is an NFT marketplace. We will be uploading metadata up to IPFS. You can do that through Infura as well. They have an dedicated IPFS gateway you can create for yourself. As always, Metamask, you need that for everything. And then Gurley ETH, Optimism Gurley ETH. And specifically, I was going to mention Gurley DAI. So when I was talking about the part where we're going to do the script with the SDK, when we're transferring tokens, the one we decided to choose was DAI. So if you want to actually run the scripts, you will need some DAI in your wallet in order to do that. The process for doing it, I'm just going to quickly say, is take Gurley ETH, go to Uniswap, change your testnet over to Gurley, and then do the swap between Gurley ETH and Gurley DAI, and that's how you do it. So are we doing this live? No. I'm just going to walk through all the contracts, and hopefully you will understand. If not, I can't explain it to you over and over again because the Wi-Fi is not my fault. So let's move forward. I'm going to go ahead and open up the first part. So this is kind of small. So, yeah, you're welcome. I'm unimpressed that your eyes are that bad. Anyways, okay, so like I said, the first thing you would do, assuming like let's say we're not in this UI, is a Truffle unbox Optimism bridge, and then if I wasn't here, I would have called it Devcon demo, and it would manifest this box, right? And so I'm going to step through what's in this box that makes it Optimism compatible. So the first part here is going to be your contracts. So in a multi-chain world, you're going to have different contracts. We should separate that logically into Ethereum contracts as well as our Optimism contracts. This contract is a meaningless contract. We just have it there as an example for you to look at something. I will explain that later. Migrations, is how we're going to do our deployment. Specifically in Truffle, you have the ability to number your migrations or your deployments, so which is really helpful for multi-chain deployments because then you can decide, I care about this migration in this order, etc., which is why they're prefixed by numbers. The next piece is scripts. So this script is actually just calling the different migration functions or doing the different deployments. I want to speak specifically to the syntax right here, right? So the first thing that we're doing is going to be deploying to L1. We choose a network, which I've defined in a Truffle config. And by default, actually, you know what? Stop. This is really hard to explain until I've explained something else. So let's pretend that never happened and move on to this portion right here. Okay, Truffle config. This is the last part for configuring a Optimism dApp. right? So we have two different configs. The first one is your vanilla config. This is what Truffle will default to if you don't specify a network or a config. Essentially, all it does is define your build directories, whatever, and then your networks. I want to note one thing. The default would just be like a build to normal contracts. But in this case, we have due to two different types of contracts, we will need to specify the build path. So that's build/Ethereum contracts, as well as, hey, Truffle, what contracts do I use? Well, you pull it from /contract/Ethereum. And then here is just identifying the network. And as always, specifying your private keys. That sucks, but I'm not going to show you. But I can show you the way to circumvent it later, which is cool. That's a sneak peek. But anyway, so that is what our truffle config looks like. Let's move back into our migration script. Now that we understand that, this is the first part. We're using our first truffle config. We are deploying to our L1 on the network girly. Like I said, with that 1, 2, 3, 4 process, we actually have the ability to specify which deployment we care about. In this case, we care about the first one. The second case, if you notice here, we are choosing optimistic girly as the network we're going to deploy to, and then specifically specifying this configuration. So that way, when we run this migration, we know, hey, we're going to pull our contracts from the optimism folder. Hey, we're going to build everything into this build/optimism. And again, kind of this specification of whatever, and then skip dry run, self-explanatory. You're just skipping the extra part. These two pieces as well, I want to do note is kind of anti-pattern. I am sorry. But this is the part where we will actually be calling the messages on each contract. So if you look in the actual deployment, you can see right here, we're getting the instance of like the greeter contract on the other L1 and setting that greeting. Typically, stuff like this where you're interacting with your contract might exist in your DApp or in a separate script. Migrations are for deployments. I just put it there to show you, hey, you can put 4 migrations in, right? So it still works, but don't do this. Anyways, so that's the structure of the truffle box. Let's actually now talk about how to integrate optimism contracts into your DApp. So let's start with the contracts. This is the transfer data section, not the SDK. So Optimism has already deployed this example contract onto their various test nets and main nets. So again, you can find those addresses in their GitHub. Essentially, this is super easy. All it does is this contract, which does a version exists on L1 and a version exists on L2, has the function set greeting. So if you set the greeting, say hello, and you call contract.greet, it will say the hello that you had put in there. Cool. And then this part here is just getting the appropriate cross-domain messenger sender address. So each of these, addresses are the cross-domain messenger solidity file that exists on each chain ID. I guess like these kind of don't matter because all of it's deprecated, but it doesn't matter. We only care about 420 and 5. And then this is how you're going to get the actual domain sender, so the OG contract that you care about. So that's kind of the base contract of what's already deployed. Now, say we want to create contracts that interact with that. So we have this greeter, which exists on L1. Again, all it does is have this function called set greeting. So if somebody calls set greeting, what we care about is number one, the message. This is how you're going to encode that message. So this is set greeting from that whatever message you're sending in. And then specifically, you could put a different contract address here. This is the permanent address of the greeter contract on the L2. So essentially, if you call set greeting on greeter L1, it will call the set greeting function on greeter L2. Hopefully you digested that. L2 does the same thing. Again, talk to me afterwards. I have so much free time. Anyways, greeter L2 does the same thing. Set greeting, again, right here, is going to be calling this function on greeter L1 and telling it, hey, this is my target, blah, blah, blah. Oh, and then gas. Like I said, gas limit is irrelevant. We have up to 1.92 million gas for free. Calling set greeting on Optimism, hopefully, I'm going to say 100% does not take 1.92 million gas. So that's where we're at. Essentially, to run this, we would have just run the script. I'm not going to run it, but you could see the output essentially looks like this, where it will compile your contracts and then start the migrations, right? So this is the first one where we're deploying it, the L1 contract, and then deploying the L2 contract, as well as then doing the fake part where you actually call the greetings. And what is interesting about this is it is calling the greeting on a deployed contract on the Gurley testnet as well as the Optimism Gurley testnet. So what can we do when that happens? We can go to Etherscan, yay, and see it in action. I'm not going to open up Etherscan. I took a screenshot. That's what happens. We opened up one of the contracts on Etherscan, called the greeting function here. So it says, greetings from Truffle. I do want to note, if you do follow this tutorial, like I said, this is a public pre-deployed address. So if all of you decide to follow this tutorial afterwards and you decide to change the greeting, you might see somebody else's. I have definitely gone to this and it's all in Chinese and I'm like, wow, Web3 is global. But you can just go back and find your transaction hash in the history and then be able to read whatever you had specifically decided to set the greeting as. And just to prove to you, this is the one from L2 setting greeting on L1. That's what it looks like. It looks the same because it's basically the same contract. Where are we? Moving on. Okay, cool. Let's talk about the script. So this is complex. But I'm just I don't know how much time I have left, so I'm just gonna talk faster because that's my style. Okay, so here is basically a script of how we decided to use the SDK. I'm going to point out a few important parts here, right? So the first part is pretty self-explanatory. We're just setting up all the things that we need to get our cross-domain sender thing set up. So you're going to need a signer for each L1, which is L1 signer, L2 signer, as well as here, this is specifically for if we wanted to do the SDK withdraw and deposit functions for the ERC20. So you're going to have to pass in what ERC20 addresses you care about. Like I said, we are interacting with DAI, so that DAI address for L1 address, DAI address for the L2 is from their list here. And so you can find it. It'll say chain ID 5 DAI, and then there's the address, and that is what you'll be using in the SDK if you specifically want to do DAI. Wanted to die. Okay. But anyways, before I dive into the functions themselves, let's actually talk about what this is going to do in the end. Super simple. Like I said, it sets up stuff. We're going to deposit ETH. So just calling the SDK.deposit ETH, SDK.withdraw ETH, and then also deposit and withdraw ERC20 and deposit whatever. I said both already. They're basically the same thing except for one caveat. So we'll dive into each of the functions and then we'll discover what's different. Cool. So after setup, I'm just going to go from top to bottom, even though logically that might not make the most sense, but that's okay. I am a bit frazzled. Report balances. Okay, this is just a helper function. All it's going to do is log what your balances are for your GUI or your ETH balance or your DAI balance. This is just for tracking purposes in the script, so you can see that, hey, it actually transferred. Wow, good job, Optimism. Okay, no one clapped. Cool. So that's kind of just helper methods. We're going to actually dive into the deposit function. So specifically to deposit ETH, super simple. You just call deposit ETH and then put it on. One thing to note here, right, is there are these things called statuses. So the problem with bridging is it takes time to move back and forth. How do you know when it's done? So Optimism will provide different types of statuses to allow you to know, hey, when it's done with relayed, that means it's been properly, I guess, committed or posted or whatever. So you need to watch out for that. And then you just report it before and after. Okay, guys, ready? What's different here? No one knows. Okay, cool. This is different here, right here. So again, like I said, we have that caveat of the L2 Optimism standard token bridge needs to know what L2 address you are interacting with. And specifically, in order to do this, you need to give approval to say, hey, I approve that we are using this L2 address. Because if you had given it a random address it doesn't understand, all of that token is gone. So this is a very manual step that you have to take in order to complete a ERC token transfer. And then we go into the withdraw. This is exactly the same thing between the two. I just want to call out specifically, we've added in a new status. So when we talk about going from L2 to L1, I had talked about that thing called challenge period, right? Because that's when like things get real, right? It goes to mainnet. So that's kind of, I'm just logging that to say, hey, I'm in the challenge period. So if you run the script, once we get to the withdraw part, that takes a lot longer than the part where we're just depositing, because we have this part where we have to wait for people to be like, no, that's wrong, or yeah, that's right. So yeah, that is using the SDK. Let's move on into actually building a dApp and seeing that how we can integrate the SDK into our application. Wow, I did so much live coding. Here it is. Okay. Essentially, I'll tell you two things I did, or I did a lot more things than two things. First off, right now we have a client in. So when you're building like a full end dApp, you probably want to, no, not probably, you should be separating your folders into your client section and the part you care about, which is your contract section. So essentially what I had did in this process was just copy paste all the relevant smart contract or truffle code into this truffle folder. We didn't need any Ethereum contracts anymore because that was for the greeter example. I just replace them with optimism contracts. So this is specifically just a optimism NFT contract, as well as a marketplace contract that handles all of the transfer of like list, buy, etc. One thing to note here is if you notice, nothing really looks any different. Optimism is EVM equivalent. So when you start writing your EVM or optimism dApps, you can pretty much copy paste. There is a caveat though with like 4 opcodes that are a little different. You might not run into them. I'm not going to get into it, but please be like aware. I am not preaching like the golden standard of EVM equivalence. It's like the golden minus 4 opcodes equivalent of EVM standards. Anyways, in this case, right, so now we actually have to deploy our contracts. I hope this will work. This is the part that I wanted to say was really cool, so I don't have to show you my environment keys. Is specifically, there's this idea called truffle dashboard. And it will open up this UI that basically allows you to connect to your Metamask account. Wow, everything is so small. Hopefully you can see it. No? That didn't do any. Oh no. Okay, well, anyways, dang, this is loading. Oh, okay, cool. Okay, so it's committed to my, oh man, this is gonna take a long time. How much time do I have left? It's 11:30. Oh dang, I finished all this in 30 minutes. Wow, we have 20 minutes for questions. Okay, sorry. um, I was so surprised. It's not connecting. Okay, I'm just going to explain what would have happened here, right? So essentially, oh, actually, I never deployed it. That's why nothing has happened. Let me go backtrack. So Truffle dashboard, this is usable with any project. If you notice, it is open up on localhost 24012. I'm sorry, I see someone squinting in front of me. Yeah, whatever. Where is it? It opens up on 24012. So if you are using like a hard hat config, for example, the way you do it is you just specify one of your networks as dashboard and that local host, and it will open up this UI. Specifically, what's cool about this here, is this my terminal? Oh, it is my terminal. Nice. Okay. I don't know where I am. I have Truffle dashboard open somewhere. Okay, cool. So you would just do a Truffle migrate, and then this time we're choosing network dashboard, and then the config is going to be truffle config.ovm.js. And I think that's it. I do want to know, as part of this box, that we have provided like npm scripts that you can just run, but I always forget what they are. Dang, where am I? I don't know. I don't remember what I'm doing here. What is wrong here? Cannot find dot. Oh, did I not migrate it in? Oh, did I spell it incorrectly? Guys, did I spell it incorrectly? Truffle-config.ovm. Where? What? Am I in the? Oh, I'm not. Yay! Live coding. Okay, so now if this works, I have 30 minutes for this to wait, guys. I really want to show you this. Damn, something else happened. Please check that your Ethereum. Oh, does my localhost die? Oh, I did. I did. Oh, I did this on purpose so you guys know how to use it. Haha. Joke's on you. You thought I didn't know what I was doing. I do, because I work for Truffle. Okay. So I think it's connected now. And okay. No, what happened here? Oh. Heard someone like trying to suggest like, hey, you just opened a new terminal. That's why it's not working. Okay, compiling your contracts. Nice. Okay. Oh, wow, fancy. Ooh. I'm so happy you guys clapped without me coercing you. This is awesome. Okay, cool. And then if you notice here, actually, I did want to point out in this migrations contract, we are deploying both of them. The marketplace contract is dependent, or sorry, the NFT contract is dependent on the marketplace contract. I did that specifically because when we mint and transfer NFTs, you need to add approval for it to do that. I got lazy and said, hey, NFT, just set approval for anything that is a marketplace contract. And that is why that is there. And that is why we have a second transaction to approve. Nice. Okay, very good. And then we deployed it. And oh, I forgot to mention one more thing. When we were doing this, right? If you remember the first time we did it, we specified the build path of contract or build slash whatever. But now that we are using it inside of our client, you have to replace that build path to be used in your client directory. This was a pre-configured project, so I forgot to do that. But I remembered, and it's already done. Wow. Okay, I'm not gonna make you clap again, even though I really like it. Cool. And so the client portion. This is also pretty. It's a lot of code. I'm not gonna dive into it. It is a Next.js project. Just kind of the steps to do that would just be like a create next app, and then I'm using Tailwind because I suck at CSS, so that's like init Tailwind. I have instructions somewhere. I'm not gonna show you. I'm gonna blame it on the Wi-Fi again. But essentially, what that looks like is we have a bunch of different pages, and I think because this is gonna be local, I can just actually just do this. Cool. Wow, local development is so good. If only there was something called Ganache forking that could fix this. Okay. Anyways, so this is kind of like the different views that we have, and I want to talk specifically about the Gurley Bridge. So I embedded it here. What does this actually look like in terms of code, right? So let's open up Gurley Bridge, and actually, let's also open up this guy right here. And you'll see the magic of how much code I did not write because of a truffle box. Let's say split left. So all we cared about in that bridge was transferring ETH between the two, right? So if we're here on the Gurley bridge, here's all the gross HTML stuff that I hate because I was never a front-end dev. But we have two things we care about, right? Depositing ETH and withdrawing ETH. So if we look at the deposit ETH function here and deposit ETH function here, don't they look almost the same? Yeah, wow, very cool. I copy and pasted that, except added some other things that you need because state matters and whatever. But you get what I'm saying, right? It's exactly the same, right? The same thing with withdraw ETH here as well. Or I don't know where it is. ETH. Yeah. And it looks virtually the same as well. The only piece I took out here is going to be report balances as part of my UI. I pulled that out into just a get L1 ETH and a get L2 ETH, specifically so that we could demonstrate this information right here. I'm not, I guess we could try. Okay. Well, everyone pray for me. Why did I do this? Inspect console. Okay. So if I do something like 0.001, I deposit, you can see like the console stuff that I had before was, damn it. Oh, this is something that, yeah, okay, sorry, I forgot to configure some stuff. So let's pretend I configured everything properly and then it understands the RPC URL and everything, but I have a screenshot. And that's all that matters. So, ha ha ha, Emily did everything correctly. This is what it looks like. And this specifically is the version of like moving it from, oh, that's highlighted in blue. Awkward. Okay, anyways, this is the part where we're migrating over Optimism Girly ETH over to Girly ETH. I do want to note one thing actually now that I remember when you're moving from L2 to L1. And you remember I said it's like more expensive because you have that double transaction, right? So in the script, when we move it over, we actually add a little bit more ETH than we directly are transferring, because otherwise that would be burned as part of the process, and you would probably actually lose ETH. So that's one thing to notice. But anyways, this is when I did everything correctly this morning, and it failed now. But that's what it looks like. And that is, I think, our full DApp. How much time do I have left? Wow, good job, Emily. I have 20 minutes left, so we can talk about what's next. So, what's next? A crash course in what's next? Just kidding. That is not the definition of a crash course. So, we're just going to talk about it. I went through this really fast, right? And this was like the NFT marketplace utilizing the SDK scripts. I would challenge you guys to actually take this information and build something on your own, right? So maybe like a chat messenger between L1 and L2s, right? Because you can transfer that data. In this case, you will be needing the truffle stuff to be deploying information back and forth. We have a vanilla optimism box that doesn't have any of these additional scripts and environment variables and everything. If you don't want that, it would just be a truffle unbox optimism. But other things is like Bridget. There's a whole bunch of bugs with Bridget. I didn't do any like data validation, fix those for me. Alternatively, like it only does ETH right now, only on Girly. You can configure it basically to select the network. And then always like I was talking about optimism because that's what we have. We have other L2 boxes. Specifically, Arbitrum exists right now. What's in the works is actually a Starknet box, which is super cool. How is Truffle working with a non-EVM compatible language? I don't know. We'll find out. That's in the future, but it's happening, and it's exciting. And then just in general, I want to talk about what our plans are for multi-chain. So again, like I said, multi-chain dApps are hard, complex. I said a lot in 40 minutes. I don't know how I did that. But what are some kind of pieces that we thought was difficult about our demonstration that we are fixing? So first thing is declarative deployments. So if you remember in that scripting portion, it was very simple. I just had an L1 and an L2, right? But imagine if now things were dependent on each other's addresses, or now we've introduced like a new L1 or a new L2. These scripts, like in production, can get really intense, and that's hard to maintain. So declarative deployments is essentially you saying like, I have a JSON or a YAML file. We're still figuring out the actual structure of it yet, but you'll say like, this is kind of what I want it to look like. And then Truffle's like, wait, I'm so intelligent. I can do it for you. And that's kind of how it goes. And along those lines of what comes with development, declarative deployments is being able to declare environment-based configurations. So again, if you remember when I was talking about the network configs, it's just like a bunch of lists of like Girly, mainnet, Sepolia, etc. But what if you could actually bundle those up into your own environment? So you'll say, I care about these networks only in testing. I care about these networks only in production. Instead of doing like a truffle migrate and specifying every single network, you could just say truffle migrate testing environment. And that's how you would get there. So that's pretty cool. Ganache plugins, I'm actually probably the most excited about this because the Wi-Fi was bad here. It would have done everything locally, right? So the reason I had to go on Girly and Optimism Girly is because we were interacting with pre-deployed contracts. So if you do like vanilla mainnet, Ethereum development right now, we do have forking, right? Where you can basically copy the state of the chain, mainnet, Girly, whatever you want locally. You can unlock wallet addresses so you can pretend like you're somebody and interacting with those existing contracts on your local environment. But right now you can't do that for L2s because there are very slight differences you technically can. I would not recommend it because of those slight differences, right? And so imagine in a world where we have Ganache plugins, and essentially you can say, hey, I want to create this plugin to create a Optimism flavored Ganache or an Arbitrum flavored Ganache or whatever. And then because of that, you can bring up multiple instances of Ganache, your Optimism Ganache, your mainnet Ganache, put those in a workspace that will interact with each other. all of those pre-deployed contracts were actually also copied locally because of the forking. And I could have just done this all on localhost. And because it's done on localhost, Ganache is compatible with our other development environments. So again, I'm here to say we do not require you to work with other or be married to Truffle itself. We are co-opetition is what I call it. And the last thing, I think I've caveated this so many times. I am not an expert, but we are bringing on an expert. So if you don't know, I do this weekly live stream called Web3 Unleashed, where I basically say, hey, I'm interested in this. Who do I know or can I figure out will teach me about it? So we're bringing Annie. She does like protocol partnerships with Optimism to come talk a little bit more about bridging, security, and then specifically, if you guys don't know, Optimism had like a huge announcement about like bedrock changes. I don't know what's in it. Annie will tell you. But this is coming up on November 3rd. It will be, what do you call it? Recorded, so you don't have to join live if you don't want to. But that is everything. So thank you so much for joining. Follow me on Twitter. That is a QR code to more of links that are important to me. Man, I'm so scared. I'm not ready for 13 minutes of questions. Usually I just take the full 60 minutes and then run. So if you have any questions about this, my life, okay, yes.
Yeah, you spoke a lot about the calling the smart contracts from one chain to a rollup and in a back way. So the question is it possible to call the contract from one L2 chain to another and
Between L2s and L2s. Okay, I don't work for Optimism, so I don't know. My guess, and I'm gonna write this down so I can ask Annie. My guess is probably no, because we are interacting with those pre-deployed cross-chain messengers, and that is what is doing like the communication, right? So maybe they have deployed ones on other L2s. The L2 space is really crowded and they're fighting each other, so I don't know if they would actually do that, which is antithetical to the spirit of Ethereum. But yeah, that's my guess. Let me write this down. Oh my God, my notes are so messy. Where's my phone? I'll write it on my phone so you guys don't see it. Oh shoot, where's my phone? Okay, I'll just remember it in my head. But yeah, cool. Do we have any other questions? Yeah.
So is there a way to hold like build directories for different chains?
Yeah. So different build directories. So if I bring up the code again, basically for each chain, you would write your own truffle config. And then why is this not opening? Oh yeah, it is here. Each config, you would just specify which build directory. You would have different configs. And that's the problem, or that's what's painful about it, right? And that's what we're trying to fix with declarative deployments. Yeah. Yes.
Are there cases where you not use
I should not use what?
Are there cases where you even with a one or no?
Oh, like when should we use L1 versus L2? I guess my specific thing is like I think L2s are the future of Ethereum. The problem with L2s, like I had mentioned, is probably the UX problem as well as the adoption problem. So when we are building, like say your first DApp, right, the biggest kind of cohort of people you could take on is probably going to be just mainnet or Ethereum development, right? But if you're trying to do like plan ahead and stuff, I'm thinking layer twos are important. Okay, wait, let me backtrack. Let me just talk about what I would think about when I'm choosing where to develop, right? So it's who is my audience? How big is that, right? The second piece is dev support. If I am building this, how good is that layer two at providing support? How good is their documentation? Stuff like that. And then the third piece is also just like general adoption of developers, right? So if you look at that space, is there anyone who can even code with you? Is there anyone you can build with? And layer twos are new, right? And so there is going to be some trade-offs there, but it's kind of what you want to do in the future. I know Optimism is doing really cool stuff with promoting L2 dapps, and I think in general, if you talk or I'm not going to say words for other people, but the general consensus, right? And the way I see the ecosystem moving is in this direction. So that's my opinion. Yeah. Cool. Any other questions? Yeah.
Yeah, related to what you just said, well, this is optimistic rollup, right?
Right.
So it is going to change eventually your knowledge because all of this time to
Right.
verify all the
Yeah. The challenge period is a big con. Right.
so eventually all this process to set layer one, layer two is gonna change as well.
Uh, I don't think it would change in the sense that if you want to interact with like a layer two, like a zero knowledge rollup, right? You still care about where those contracts are coming from. So that build directory is still important. The network IDs are still going to be different where you're deploying to. So all this different configuration is going to change. Actually, I did mention, so we have StarkNet is zero knowledge. We are working on a ZK sync integration as well, which is also zero knowledge. So I think regardless of where you choose to go, this is going to be a configuration you still need, unfortunately. But I think hopefully if you have submission or like, what do you call it? Suggestions, whatever, like we're open source. Why don't you just contribute to our code base or create an issue? We have GitHub discussions as well. Join our Discord community. Blast me on Twitter. Whatever is most comfortable for you. But yeah. Yes. Yeah. Oh, sorry. Okay, you said I love. Okay, disclaimer: part of my personality is I really like fried chicken. It's on my Twitter. That's what he mentioned. If you didn't hear that, so okay, yes. Oh, wow, we're getting professional, like personal here. Dang. Okay, we have 7 minutes to answer questions about Emily Lin. Okay, why did I choose to go into DevRel versus, be a core developer? That's a great question. So if you want to talk a bit about my background. So I graduated college with a CS degree. I went immediately into back-end development. I did that for like 2 years and then was like, oh, this is kind of boring. What's cool and fancy? And I was like, wow, DevOps is such a sexy word. It is the worst word ever. I hate Kubernetes. But anyways, um, I moved into DevOps, right? And I think I'm in my 20s. I don't know why I'm getting into this tangent. But I was kind of in that space of like figuring out I'm not totally satisfied with my job. Part of the reason I moved into DevOps was one thing, it was sexy at the time. Um, but like also like I really wanted to learn something new, right? And I haven't got to the DevRel portion of it. I promise we'll eventually get there. I'm just filling 7 minutes. But where was I? So I knew I wanted to do something where I was always learning something new, right? I felt like within my engineering job, there was a lot of like communication internally, like with my team and building projects. And I really liked that. But at the end of the day, I think when you are plugged into like a big tech company, for example, I felt to an extent like I don't want to call it code monkey, but the impact I had was not as big as I would hoped. Right. So when I was thinking about, what are my next career steps? So I actually didn't get into Web3 or DevRel until this year in March. So I'm relatively new. But the thing I cared about again was, work environment. I wanted to be around builders. Like it was really important to me to be around people who like really passionate about their work. And like maybe unfortunately crypto is usually our 24/7 and not our 9 to 5, but I seek that kind of environment. You know what I mean? And the second piece was the thing I enjoyed the most about my engineering job was the cross collaborative communication. When I got to kind of background wise, so my when I joined the DevOps team, we were really focused on reaching SOC 2 compliance, so security. So I was working very closely with the security team. And so being able to translate technical concepts on our side to other team members was something I really enjoyed and knew I wanted to take into the next job. So when I was considering my different options, developer relations came up. And I thought it was this perfect marriage of I get to keep my technical skills. I am required to learn something new all the time. So that's why I'm not an expert in anything, obviously, but I know a little bit about everything. And I think that is something I really liked. And then in terms of the impact part, just being able to interact with devs, like my job is figuring out like what pain points people have, what they're working on, et cetera, and like trying to fix that, like felt more tangible to me, right? And I think that's why I kind of fell into DevRel. I'm going to say one more thing, and I always say this, and she's in this room, and she hates that I say this. My sister actually started in DevRel first, and then also works in DevRel in Web3. Uh, yeah, wow, crazy. And she is like one of the biggest inspirations in my life. And so maybe that's part of my motivation as well. Or maybe I'm just like the bratty little sister. I think my tagline is like do everything she does but better. So maybe that's also why I got into DevRel. Cool. I don't know if we have any more time. We have, oh God, 4 more minutes. Dang it. Okay. Otherwise, feel free to go wait in line for other talks or come catch me wherever. Yeah, I mean, I'll be at like the conference. I'll be at NearCon. Consensus, which Truffle works for, is going to be having a event this Friday. So feel free to stop by. We have a lot of different panels and things like that. Yeah, cool. Thank you so much.
Yeah. Oh, awesome. Hi, guys. I'm Ben Mimishevich. I'm a software and smart contract engineer, been in the space since about 2018. Today, I'm basically going to do a tutorial where we'll build through a simple blockchain indexer and just sort of explain how indexes work, different pipelines you can design and make, and in general, just interacting with Geth on a sort of RPC level. Okay, just some background quickly about me and how I would love to run the presentation in general. Yeah, so as I mentioned before, I've been in the space since 2018. I used to work at a consultant in Labris, which is an Australian smart contract consultancy. And then I worked as an engineer at TracerDAO in Mycelium, which is a perpetual swaps protocol on Arbitrum. Yeah, I was the team lead at Reputation DAO, which was a project at Mycelium, where we focused on indexing and monitoring Oracle systems on chain to make sure Oracle's essentially held accountable, and also that they're functioning properly and accurately. So sort of just detecting errors sort of in that pipeline. So in terms of my experiencing in the indexing space, I've been working in indexing for about 2 years. I like to know what I'm talking about, but I guess we'll see. In terms of questions, please just like shoot up your hand if you have anything as I go. Okay, Etherscan. Etherscan is probably the most popular indexing tool all around. I've spent a lot of time on Etherscan. It's basically a hobby of mine. I'll click through random blocks and see if there's something fun. If you've ever accidentally sent ETH to a contract instead of calling the function and you think nobody saw it, I saw it. So this is one oh, there's a screen here. This is just one address that I found this morning in a block. And it's essentially an EOA that seems to be fanning out ETH to a bunch of addresses extremely quickly. So it's sending out 4 or 5 transactions, trying to spread out, I think, about 0.8 ETH. Yeah, but it's really worthwhile if you haven't done that to sort of explore what's on Etherscan and see how interactions are happening on chain. Okay, so observability and transparency. I know at the moment, ZK and privacy in transactions is highly important. And that's absolutely true. And if you want privacy in your transactions, go for it. But on the other side, observability is also highly important. Just as a question, does anybody have any pros that they think having transparent transactions have over ZK? Yeah. No corruption. Exactly. Nice. And I'm not trying to just shield transparency. Don't worry. I don't work for the SEC or anything like that. I'm not after the taxes. But it's still highly important in certain systems. Oracles, which I work for, don't really function on zero knowledge. You have to know that your oracles are operating properly, and you have to know what each oracle is submitting. Having anonymity there reduces the accountability of those oracles, and it can cause your systems to not function the way you hope. If one bad oracle transaction can completely crash a market, especially derivative markets. This is actually one example here, also from this morning. So Mongo markets lost $100 million last night because of oracle manipulation. So making sure that you can observe what's happening and also the exposure that those oracles have onto each market is very important, and something where transparency and building an indexer is highly useful. Okay, what actually is an indexer? The way I define an indexer and the way I like to think about it is it's basically an ETL program where your backend is communicating directly with the node, you're requesting data from the blockchain, and you are converting that data or storing it in a unique way that makes it more accessible or useful to you. Yeah, sorry, let me just run it here. So why would I actually want to store it differently than on-chain? Because the blockchain is a database in and of itself. All the data is always there. The problem becomes, though, if I want to retrieve specific data or a range of data, or God forbid, create some sort of average across it. So if I wanted to do that, I might have to make hundreds of ETH calls to process one transaction or one event that I define on-chain. So one really popular reason to make an indexer, which a lot of now RPC sort of services like Alchemy and Coinbase support, is to fetch the transaction history of an address. That is not possible directly when you're directly interacting with the node. You would have to pass through every single block that that address has made a transaction on, and then manually look at those transactions. Another really good reason is non-ephemeral data on the chain. So mempool data, anything that you run through as a test as an ETH call, doesn't stay on the blockchain forever. mempool data in particular is highly useful for arbitrage strategy, but there's actually no consistent history of the mempool. Obviously, mempool also differs from node to node, but having a history from a range of nodes is highly useful if you want to sort of backrun strategies that you could have done if you're an arbitrageur. Yeah, also gas estimation as well. If you're making ETH calls that don't actually go through chain, you want to have a history of how your contracts will look when they're finally deployed. Creating a mini indexer that runs off your local host smart contract node is absolutely a valid option. Now I just want to quickly break down a log that happens on chain quite frequently. So this is what happens when a Chainlink oracle submits, well, lots of Chainlink oracles actually submit an answer for a price feed on chain. So this is the decoded version. I'll show you the encoded version a little bit later on. But even here, not everything is super obvious to the eye, right? So you have the answer at the top, which is obviously the new value that price feed will have. For those curious, this is the price of 1 inch. But there's other points that are really confusing, right? If you look, there's observations where you have what seems to appear as a int array, right? And you have observers, which is just this confusing byte array with a weird name. You have raw report context. Let's sort of just look at what's going on. Okay, so step 1 to creating any indexer, or sort of observation solution is first you have to understand the contracts that you're working with. What your ETL really does and what it should aim to do is to take this raw hex data on chain and give it new meaning or new accessibility. And to do that, you have to know what the contracts are doing already. Just copying the data across isn't really enough. So sort of on that point, I'll just quickly explain how OCR works. That was the Chainlink log that we just looked at previously. So how Chainlink operates nowadays is that, also I don't work for Chainlink, I just want to say. How Chainlink operates now is that most of the aggregation and collection of data happens off-chain. So a price deviation will happen. All these nodes will look at their different APIs, and they'll send all of their answers to a single node. And then this node will submit all of these answers and the final aggregated answer on chain on behalf of everybody else who's supporting that price feed. So sort of knowing that, I'll also just go through a simple timeline. So as an example, say I have a Chainlink feed that's monitoring the price of Ethereum. When the price of Ethereum dips by a certain percentage, all the Chainlink nodes will know, and they'll start a new round. Every single Chainlink node will then send an answer that they've collected from their APIs to a leader. That leader will aggregate that answer, normally taking a median of some sort. He'll pass this along to the elected transmitter for that round, and then that transmitter will send off a message on chain containing all the information that everybody submitted individually, as well as the final answer. And why I sort of went through this is by knowing this information, knowing how the system works, we can now make sense of the log that we looked at earlier. Okay, so believe it or not, this observers array right here, byte array, is actually a list of the addresses that each of these observations come from. So if you, all those numbers, there's a corresponding oracle address of the oracle that submitted that answer. And that answer is the number that they thought is true. Another thing to note is that number is very large. Yeah, if that number was exactly how it is, I would be retired as holding like 51 inch tokens. But here I am. So this is sort of another step we have to overcome. So we're sort of missing more information, but we know it's available somewhere within the contract. So this information is available through a view function in the Chainlink aggregator contract called transmitters, which returns a list of the addresses of each oracle that is supplying that contract with data. And there's another function called decimals, which tells us by how much I should divide those numbers, those observations, to get the accurate, like human readable price of 1 inch in this case. The problem, though, is that these variables can change block by block. These are adjustable variables. Transmitters change all the time. Not only for security reasons, but sometimes certain oracles are better at performing on certain feeds than others. And decimals can change when different markets require more precision out of a price feed. Okay, so this is sort of how we break it down. So I had my observations arrayed there, and the way to break it down, and you can find this out by sort of reading the contract and then doing a bit of guesswork, is that if I look at that byte array and I split it apart into pairs, each of those pairs can be decoded from hex into a number. This number represents the index of which that observation in order corresponds to which item in that transmitter's array the observation was from. So in this case, the second observation here was from the second oracle, so we're indexing from counting from 0. So 0x0312EA ... responded with 439399 blah 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 blah. So already we're sort of getting kind of complex in how we're just deciphering this one single log. So we'll go through the steps in code as well, how we would do all the different calls. But essentially, at the minimum, what we have to do to fetch this data is first we have to encounter this chain link log. Then we have to pass the data back into regular data types, take out transmitters, byte array, break it up into pairs, convert that into hex to get a number, call the transmitters function with an ETH call, and then pass out which address is with which address. Now, doing this for one log, not too bad. I probably wouldn't want to do it by hand. But imagine if you wanted some sort of aggregate data. Imagine if I told you, okay, tell me how accurate this oracle was on every single Wednesday for the past 6 months. Now you're passing hundreds of logs, you're making thousands of calls, and if you want this to be done on demand, it's going to be incredibly slow. It might take minutes. On the other hand, I could make like an SQL statement like select average where oracle equals this, where time equals this and this. I'm converting hundreds of lines of code, thousands of like HTTP requests to one line in SQL. That's sort of the value that indexing can bring. Before we actually get into the indexer, I also just want to go through the data types Ethereum has. So these are sort of our avenues into getting different data. So there's actually more than this, but this is just a quick summary. So does anybody know by heart what things that you can search on Etherscan? Well, any? Like blocks, contract addresses, any others? Okay, yeah. Transaction hashes, yeah. So transaction hashes, addresses, block number, block hash. Sorry? ENS names, yes. Nice. No, you cannot. Not within the like top search bar, yes. So these things are the things that Ethereum will naturally index. So you can already select these from the node relatively quickly, and they each have a relationship with each other. If I have the log, I can retrieve the contract address that that log was emitted from, and I can also retrieve the transaction that that log came from. And then through that, I can also retrieve the block number that that transaction happened on, and so on. And receipts as well. So transaction receipts, so I can see how much gas was paid for that receipt. But the point here is that you're sort of migrating across these different data types to collect all the information you need for your index. So, dissecting a log. I'm just going to go over the structure of logs. And for those curious, the reason why I'm concentrating on logs is that there's quite a lot of functionality within the Geth client, or with blockchain clients in general, for creating these indexers based on logs. Creating them based on transactions is also possible, but a lot more manual. You have less sort of filtering power on that first step. So how a log works. So logs are constructed out of topics and data, essentially. So topics are also data. Topics 1 to 3 are data types that you can emit in your event and mark them as indexed. And why this exists is that instead of building an indexer, I could potentially just use the blockchain client as well to look for cases where the data is equal to a particular amount. So I could tell Geth, tell me when topic 0 is equal to X and topic 1 is equal to this, and retrieve all those cases for me within some block range. Topic 0, I'll go over in a moment. The data, something to also note on topics is that you can only index up to 3 fields. Data, though, you can throw as much stuff as you want in there. And this is like highly valuable. And a good way to think of logs and data in general is sort of like a print statement for your smart contracts. So if you've ever like debugging and, you know, we're all programmers here and we hate using the actual debug tool, so we just print hello. This is exactly what a log is. Yeah, so we also have the transaction index, which is at what point our transaction appeared within that block, and also log index, which is separate, which is where this log appeared within that block, which is normally completely different. There's also removed, which is like a bool that just signifies if our log was removed from the canonical chain due to a reorganization. Topic 0. Topic 0 is highly useful. Topic 0 defines the log, I would say. So what topic 0 is I take my event definition. So say I have an event called transfer, and it takes a uint as an argument. I want to look at every single instance on the blockchain where this transfer event happened. And to do that, I have to calculate topic 0. And to do that, I take the CAC of my event name, so transfer, and then each data type that is within that event definition. So here it would be, you know, uint 256 or whatever. Some important things to note: you do not include, and I learned this painfully by experience, do not put spaces between the types because your hash will be wrong. And also don't put the name of the variables within the type because the EVM doesn't care about that. So something to note as well is that this topic 0 is unique for every single contract. That is to say that you can only have one event with one exact hash definition per contract, but this is not stipulated across the whole chain. So I could potentially say, look for every single log with topic 0, but I might actually collect data for 4 or 5 contracts that are doing a completely separate thing. That's just something to be wary of. Storage. Another really cool thing that you can do when you're building an indexer is accessing the actual contract storage. So private variables now become completely accessible to you. This is really good. One of the main use cases that I've certainly used this for is when a contract is implementing EIP 1967, which is the proxy pattern. So you have a contract that's implementing all the calls from another contract, and that contract's address that's actually got the implementation is always in a specific storage slot. I can go into this example later as well, but this is just one hugely powerful example of stuff you can access if you're building your own indexer. Okay, infrastructure design. So this is a bit of a Web 2 thing, but it's important to think about how you want your indexing application to run. You can make it as complex or as simple as you want. So if it's just a regular ETL, you can have your program connected to a node, and then you're inserting into a database, but you can do so much more. You can create a hackathon submission that is looking for events on Lens, for example, and then I'm sending out alerts through EPNS every single time someone's profile gets liked. I could take, I could scale my application. I could have several nodes, have a load balancer between it, so I'm not overwhelming any single node. I could be sending off my messages after I've dealt with them to an AI analysis, and I could be storing them across several database nodes. Stuff I've worked with personally that I recommend is a sort of microservice architecture. You can have Kafka sort of in the middle as a message broker and pass information between all your services, all your different storage points. Maybe you're an arbitrager and you want to do sort of an analysis, throw that analysis inside in-memory database like Redis for quick access, while simultaneously throwing any archive data into your own sort of Postgres database. Database options. So indexing is really powerful because you can choose how quickly you want to access what subset of data. So these are just like a few I threw up. So timescale DB is extremely interesting, but any time series database sort of proves this point. The blockchain doesn't give you an option directly to look through transactions within a time range. You can specify a block range, but that's not really always ideal. Blocks take a different amount of time to create over time, and you have to do sort of extra legwork there if you want to convert from block to time. Timescale offers something really awesome, especially when you're looking at a large data set like a blockchain, and that's continuous aggregates. And these are materialized views that you can create for aggregate data. So, for example, I can calculate the average every single week of how much gas is spent on Ethereum, and I can permanently store that data in a view and access it instantly as opposed to having to recalculate that data. KDB is very popular within sort of the MEV community, from what I've seen. It's a completely in-memory database. It's extremely fast, so similar along the lines of Redis, but far more performant. It's used a lot by quant firms, arbitrage, and also Formula One, like racing. So they use it for in-race analysis and stuff like that. Postgres, absolute classic, completely free. Perfect RDS system. Why would you use anything else? Don't talk to me about MySQL. I hate it. Okay, now I just want to go through a quick code walkthrough of a simple application. So we can actually build these indexers in about 150 lines of Go code. Easy. Okay, so first I want to explain my language choice, because I've been contested on it in the past. I really like using Go for the backend and interacting directly with Geth and with the Geth library. Like first of all, Go is fast. Geth is probably the most well-maintained library. It obviously doesn't have features of certain other blockchain Ethereum clients, but it is definitely the most well-maintained, and it always fits through the specs, the yellow paper specifications. Go has a huge bonus in that parallelization is directly built into the language. So we're going to be doing a lot of calls through WebSockets or through HTTP, and we want to parallelize these, and we don't have to worry about race conditions when we're using Go. Another huge bonus is that all of these functions that we're going to call to extract data, our program is going to be completely portable to every single EVM chain except for memory XDAI. So we can port our application, make it as generic as possible, and we can start looking at events on Polygon, Ethereum, Optimism, Arbitrum, whatever you want, without having to do any extra legwork. It's like deploying a smart contract to multiple chains. And the reason this is all these RPC calls that we're making are specified within the yellow paper. So any EVM client that is being created is going to have to fit through these specs. Okay, creating a client. This is like pretty basic code. So I'm just creating a HTTP client. I'm feeding in my Alchemy sort of key. That's what the RPC thing is there. It's just a string. I'm doing a bit of error handling here, making sure that I am in fact connecting. And that's really it for this. There's really not too much to worry about here. Yes. Okay, that's a good question. I'll just repeat it. So the question was, should you run your own node infrastructure or use an outsourced node like Alchemy? So there's several advantages to running your own and a few disadvantages. Running your own node, beyond you just have direct access and you can manage all your load yourself. You can also put other sort of add-ons on top of that node you can put add-ons on top of that node to make the indexing even faster. So when you're doing retrieval, you're sort of indexing already on an index, which is fantastic. Me personally, if I'm running in a production environment and I have an application that's fully running as an indexer and my system is depending on it, then I would run my own node. I see some like node operators here and I feel bad. But for hackathon projects, absolutely use Alchemy. Fantastic solution, not just Alchemy, and any Infura, whatever. I'm not sponsored, guys. I'm sorry. I keep using the same names. WebSockets versus HTTP. So most providers will allow you the option of accessing their service through a WebSocket or HTTP. I'm just going to go over this quickly because it's more of a Web 2 thing. HTTP is normally how your wallet connects to the chain. So whenever I'm making a request, my wallet is creating that TLC connection and it's shooting back a message and that connection is then closed. When you're creating an indexer, you're going to want to make lots and lots of requests, and that extra latency between creating a new handshake every single time is actually quite cumbersome. I would just say straight up that if you can use a WebSocket connection, always use a WebSocket connection. No reason not to, really. Okay, now we're going to look how to create a query, and this is an SQL. By query, I mean we're going to query data directly from the node. So there's this Ethereum Geth object called filter query, and it does exactly what you think it does. It takes an array of addresses from which I want to collect logs from, and it takes a list of topics. So before we talked about topics and how you can index up to 3 and you have topic 0. So you can specify here, I want to collect data from which topic 0 and which other topics I want to be equal to some hex value. And I sort of just declare this object, and that's all you really need from here. We haven't actually made the call yet. This is just constructing the query. This also takes a block range, which I didn't include for some reason. Next, okay. So now we're actually making the query, and this is where block range becomes very important. So there's 2 ways in which I can request data from a blockchain node. I can do subscribe filter logs, which is I'm establishing a connection to the node, and I'm telling the node, okay, here are my parameters. Whenever this happens on chain, send me a message. So this is really useful because now I can sort of distribute my load from the node because I get these messages one at a time. I can process them, and as long as my application is at least decently efficient, I'll process everything without any lag. Now, this always isn't an option because one thing about subscribe filter logs is that I can't request historical information. I will only be receiving data from the point I've subscribed, so from the next block that's coming. Now I can also do filter logs in which I can request a bunch of logs that have already happened. So that's essentially what that does. It's really useful, especially if you want to do a historical analysis. The thing to be wary here is that it is like quite hard on the node if you're asking a retrieval of, megabytes or gigabytes of data, and also your application is going to have to keep time as well. Definitely super expensive if you want to collect the entire history for a particular log throughout the whole chain. Okay, channels. This is a Go thing, but it's also extremely important to know, and it's one of the reasons that I suggest making these index applications in Go. So what a channel is in Go is essentially like a pipe. So if I'm sending data from A process to B process, I use a pipe, but there's certain issues associated with doing this, right? So you have to deal with race conditions, for one, which is a huge headache. Also, piping can be quite messy. I don't know how you're doing it, but you can do it like through a bash script. It can get pretty weird. What Go offers is channels, and channels are naturally blocking. So I don't have to worry about message 1 getting there before message 3 and screwing up all my analysis. The channel will only send a message across to my next process when that process is ready to receive the message. And this for loop here, we're sort of declaring an infinite for loop and using the select statement, and the select statement is just saying, I've created this channel, logs1, and I'm waiting continuously until something is sent to that channel, and the blockchain node is sending data to the channel. and I will pull out that message as soon as it comes, and select is just saying whichever one comes first. So if my channel comes back with an error, I'll deal with that and crash my program, or if a log comes first, I'll go and do some processing. Okay, how do I actually process data? So when I request data from the blockchain and I get logs back, I actually get back a pretty messy data structure. Not messy, but not human readable. So what I'm going to get back is the logs data structure, which we went over earlier. I'm going to have these topics, and I'm going to have the data field inside the log. And if I'm pulling the transaction, similarly, I will have the data field within the transaction field, which is identical to the sort of log data. Now, passing this across is pretty complex. So there's natural padding that happens from RLP, encoded values, and I also have to convert from hex back into sort of regular values, at least for Go to interpret, but also so humans can interpret it. I don't really know what's happening when somebody says, oh, the value came back as like 0x, 60 zeros, and then a 3. So what we can do instead is we can generate an ABI, and this is exactly how Etherscan does it. And for those not familiar, an ABI is a specification of all the functions and all the events that happen on a particular contract. And I can generate this by going to a contract and using solc. So that's the command at the top, solc ABI, and the name of the file, or the path, sorry. And then I'll get a huge spit out of a JSON file. And we'll use this and define it as a string, and we'll use it further along. But the ABI is highly useful, but something to note is that it does not directly appear on-chain. On-chain is only sort of the compiled like bytecode. So the ABI you have to get by having access to the source code, or sometimes people upload it to Etherscan. And what the ABI allows us to do is the ABI knows, as I described before with the CAC, it knows all the input types for all the functions and all the events that are defined within that contract. So now I can use the EVM to, oh, sorry, it's plugged in. Should come back up in a moment. Okay. Oh, it is back. Fantastic. So I can use this ABI and use the EVM to decompile all of this hex data that I'm going to get blurted out back into regular data types. So creating an ABI object, similar to the JavaScript concept, but I'm going to call this ABI function, which is also ABI library, sorry, that's also part of the Geth module. And I'm going to pass in the ABI string that I defined previously. I'm going to check that it is in fact a valid string, which is important. And then I can start unpacking data. And that's that second sort of code block in there. I call my object, I tell it to unpack, I pass it in a string, which is the name of my function, and then I pass in my data. And what it's going to spit out is a huge array of interfaces. And interfaces are just generics in Go. So it's data that I don't know the type of, and I have to just tell Go which data type that is. And I can find that out by looking at the smart contract code. I can find that out by looking at the ABI. And even if I make a mistake here, Go will tell me that I made a mistake. If I try to assert wrongly that it enters a string, Go will tell me, oh, actually, you want to type assert to a string. I don't know why I can't just do it automatically, but life can't be that easy. Okay, working with a database. Okay, so now essentially what we've constructed is we have a system that's requesting data from the node, either live or through a historical query. I've collected that data. I now have a method to unpack that data into regular Go data types, and I can convert between them as I wish. Now I want to insert that data somewhere. So this is a pretty standard way of just interacting with a database in Go, completely fault-proof. And it's using a library called GORM, so GoRM. It's used to be sponsored by Chainlink actually as well. Pretty fantastic library, highly recommended. So it's very easy for what I have to do. I just define a struct which has what I want my table to look like. I throw on some strings where I want my primary keys or foreign keys or indexes, and I'll just leave that in the module by itself. And then what I'll do is I'll initiate a connection to my database, and it's also just this one-line code. So I just tell it to open. I have Postgres listed here, but it has support for most popular database management systems. And gorm config, which you can specify different things in, but we can just leave it blank. If you're not doing something fancy, you can pretty much leave it alone. I do some error checking, and then I've got migrations. For those unfamiliar, migrations are fantastic. If you've ever worked for a production system and you've wanted changes in your database, and you basically, it's like a nuclear reactor, like two people have to turn their keys at the same time to edit a table, migration sort of sidestep that. What gorm will do is I can pass in my structs that I defined before, and it'll automatically create or edit the tables that I already have. So that way, the code that I have is going to be exactly represented in my database. Inserting. So we're pretty much like done here, guys. All I have to do now is use the structs that I previously defined, pass in my decoded values, and then I just have this one line insert or update on conflict. So what this is essentially doing is I'm sending a message, and it'll be ACID, depending on your database of choice, I guess, out to the database, and I'm telling it, okay, if there's no entry, insert it. If there is, update it. And updating actually absolutely can happen. Although the blockchain is immutable, remember that the node is getting new data all the time. Reorgs do happen. So something you want to watch out for is your block hash changing, and also your block timestamp. Profile IDB. Oh, sorry. We just have like type assertion here, so you can sort of see how these are getting passed back into the struct. So I have my profile ID, and this is an example that I did based off lens. So profile ID in lens is an integer which represents your user on lens. And then also NFT, which is an NFT that's generated on lens whenever you follow somebody. And I just pass these into that struct. I'm calling my database.clauses update function, and I'm passing in a pointer to the struct. Okay, so that's basically it. I can go through some like actual examples as well, but I just wanted to do a Q&A. Actually, how much time do I have left? We've got plenty of time. Yeah. Oh, okay. So EIP 1967 basically says it's a proxy pattern. So say I want to make changes to a smart contract. You obviously can't really do that. So what I can do is I can define a EIP 1967 contract and tell it, do all the functions of another smart contract. And I can change which smart contract logic is actually being changed by just changing that variable. But the problem is that there's no like view function for the contract address that's on that 1967 contract. But the storage slot where that address is stored is always the same across any EIP 1967 contract. So I can retrieve this address, and then I can query that contract for any information that I want. Does that help? Okay. Yes. Yes, I will. I wanted to clean it up a bit, but it's it's submitted within the ETH hackathon. I can send a link out. If I'll send it out on my Twitter, which is at the end.
How many block confirmations do you wait to put your data on the database, or how you update software?
Yeah, I'll just repeat the question. But the question is, how many block confirmations do you wait before inserting the data into the database, or how do you deal with updates? So the great thing about the system is that you don't have to wait at all. Every time there's a new reorganization, the logs will be like re-put through the node, and then the indexer will automatically update that column for you. So the data you have in your database will always be the most accurate that it can be, and most up to date. Cool. Sorry, yes.
So log submission is like voluntary. It's not standardized.
Yeah.
But it's like the most useful for indexers.
Mm-hmm.
Why is it like not standard? Why is it like voluntary?
Why is it voluntary? I mean, it costs gas to emit events. Why isn't it standardized? I mean, it is standardized in development. It's not like you have to deploy a contract with events. And if there is contracts deployed without events, you can also create an indexer based on that. I think that's what you're getting at, or?
Yeah, it's just like difficult to find information there.
Oh, yeah. Okay, for sure. Sorry, can you repeat the question?
Why is it like that? Why some logs in some events and some others, but then indexers mostly use logs.
Okay. Why indexes mostly use logs? That's also, I want to say, more my opinion than true fact. But also, most popular index platforms, so the Graph and stuff, focus on logs quite a bit. And sort of why there's so many logs and you have to find the useful ones, that information is hard to come by. And if you want to create your indexer, as I said, you should know the contracts and the system. But also you can make a general solution like the graph or like, ooh, I forgot the name. Oh, can someone help me? Their logo is like June Analytics. Thank you. Like June Analytics, where I can do an SQL query on absolutely anything. But in terms of why there's so many events happening, a lot of these events are just shot out for debugging purposes and they're left in the contract, and you sort of have to decipher as you go. Any other questions? Yes. Contract state. Yeah, yeah. So as before, as I went like through storage. So if you want to, it's getting annoying. If you want to get contract state, there's three main things that you can do. So there's access through variables. So every single public variable on a contract automatically has a getter assigned to it. So that's one way where you can access state. The second one is through storage, as I mentioned before. So it's kind of tricky to find out exactly where a variable is in storage, but if you go on the Solidity documentation page, they will actually walk you through how storage is structured based on the contract, and you can sort of mull your way through and find the variable. The third is traces. So traces are the individual opcodes that a contract is pushing, which you can also request from the node. And with combination of those three, you can see absolutely everything that a contract does. In terms of sort of creating strategies based on collecting that state, I think the best indexers are ones, well, that you make yourself and they're purpose-built, and you're traversing across these different data types to create sort of your perfect arrangement of data. So I built one on top of Aave a while ago, and that was like relatively tricky. So they have a EIP 1967 pattern. We're accessing storage to find that contract. That contract is a pointer to other contracts. I'm doing an ETH call to access the variables to find those other contracts. And then I'm calling balance to find ETH balance of those contracts. I'm also utilizing storage, yeah, stuff like that. And then you just have a really neat one row item in your database for what you want. Sorry, yes. Do you mean deploying the same contract on two different chains, or? Okay. So yeah, that is actually important to note. So if somebody like destructs a contract, yes. Okay. If somebody self-destructs a contract, I'll just repeat the question. If somebody self-destructs a contract, I believe it's possible for another contract to appear on that identical address, and that can have different codes, so it can potentially break your indexer. What you can do there to solve that system is you can have a microservice looking for destruction transactions. and matching them up, doing a query in your database to see if that's affecting one of your indexers, and then making changes to that indexer live. So I'll normally do that through a microservice architecture. So I'd have one looking for destructs. If a destructs happen, send a message, adjust, or cancel my indexer for a period. The great thing about the blockchain is the data is always there. So even if you miss a few logs, you can do that historical query and rebuild your data set. Yes.
Describe the advantages of this approach when you write all the code by yourself compared to, for instance, the Graph.
Yeah, sure. The advantages are sort of okay. So specifically to the graph, I would say is that there isn't a lot of functionality, I believe, but please do correct me if I'm wrong, to do queries across different subgraphs, at least currently. Okay. That was definitely one use case when I built them. Oh, okay. I mean, okay, so number one, I would say in general is latency. You don't have to wait on any graph node operators to fill up the graph for you. Second of all, I can create a graph that is, well, a data set that's infinitely more complex than what I could do. I mean, I can theoretically do anything on the graph, but here I have very close-knit control of exactly what my code is doing and what I'm putting through. Sort of third, I have control over my own infrastructure, so I'm not dependent. The graph is decentralized and a fantastic protocol, but having your own data set with your own database that you know exactly what's happening on is extremely useful. Fourth, you don't have to pay. It's free. Um, yeah, I guess that's like some of them. But really, my main pitch for it is that this isn't that much code. It's not expensive to run. It's mainly really just doing HTTP calls. You can run this for free on any cloud provider on like the E2 Micro or whatever the AWS equivalent is. You can run it on the free tier. Superbase has free Postgres databases. You're running your own infrastructure, creating your own DApp, and it has no cost to you whatsoever. Yeah, anyone else? Yes. Yeah. So yes, there is a way to handle this, and you can subscribe new. So there's a function called subscribe new head inside the Geth client, and every single time there's a new block header or an uncle, you'll get a message there. So you can make a service where you're looking for uncles. It'll give you the information you need, and then you can look at what that uncle did, and it should produce new events, and it should tell you like the removed tag for the event for the log. So you can retrieve. So when your block hash gets uncled, like let's just assume that you detect it properly through subscribe new head. You can re-request that block through the block hash, and then it'll give you inside the log field a removed field, which is a bool to tell you if that log has been deleted or not. And if it has been deleted, then you can mark that in your database. You can delete the row, or you could, it depends on your private key, sorry, not private key, your primary key setup. You can delete it or change that variable to true that it has been removed to mark that it's not valuable data. Okay. Looks like we might throw Rave here instead. Yeah, anyone else? Yes. Yeah. Sort of hardware that you need. It's so I'll say like for a couple different components. From a database point of view, absolutely. It depends what sort of service you're running, how quickly you want to retrieve that data. But in terms of storage, I don't know. I would say maybe 600-700 gigs for the database. The more difficult component is if you want to do that historically for every single block number, you're going to run into hiccups with having nodes requesting that data from nodes. So that's going to be very expensive if you're doing that through Alchemy or Infura or one of those node subscribers where you're paying per call. And if you're running your own node, I would say 1 isn't enough if you wanted to finish like this century. So what I would do is run, whatever, 20 nodes, hook them all up through historical data, so you can use snapshots now. So it's nice and easy to set that up. And then have a load balancer and distribute out your calls into the different nodes. And that's probably the quickest way to do it. In terms of the actual indexing, pretty lightweight. I wouldn't really worry about it. The way I normally run it is have a Kubernetes cluster and then just auto scale as I need it. Yes.
But for long-term performance, what did you structure the data?
Okay.
Or
Okay, it really depends what your application is doing, but what I would say is that for long-term use, I would recommend a relational database system, so SQL, just because you can get a lot more use out of it, and if you're storing the data long-term, you probably are imagining some use cases that you don't have yet. NoSQL, I would suggest for when you need really quick retrieval of that data. But in terms of sort of data strategy, a pretty common one that I've been successful with is time partitioning my database. For those who are not familiar, partitioning is sort of, imagine you have a CSV and you have a huge Excel file. Now, instead of having this huge Excel file that I have to search through, I break out the Excel file into like 5 different files and I define them by a range. And now I can just search through that range for a particular transaction. So there's lots of time partition databases, but I would time partition your data if that's relevant, and then create indexes on everything the regular blockchain does, and also anything of direct interest to you. So just like a congruent index, so whatever you want, like block number plus the value of some variable plus like topic 0 hash, for example. Also, another good thing to do is to break apart into different tables your events. Yeah, I think that sort of goes for best retrieval. Obviously, also, if your database is getting huge, also separate it out into different nodes so you're not paying for like vertical scaling. The other one I didn't mention is graph databases. I haven't seen that much use for them. I haven't used them myself, sorry. But that's also an extremely powerful way to store your blockchain data, so I can see the relationships between different addresses, or I can see the relationship between, for example, like oracles and the Aave market. Yes.
What's the advantage of using the channel and synchronize instead of a queue and doing async for index?
Sync for indexing. So the different channels, I mean, it's parallelization, but essentially I don't have to wait for one request to get through before I do the other one. So it's very, very useful. So I'd say if you're doing the subscribe filter logs method when you're getting one event at a time, you're probably absolutely fine without using a routine. But if I'm doing the filter log method and I'm requesting a huge amount of logs at the same time, and I have additional calls to do on each of those, that's where parallelization will really help you out. You'll be able to make, thousands, millions of calls at the same time instead of one at a time. You're going to be cutting down the amount of time you need to index from, whatever, weeks to hours.
Always index in a time fashion way, first and then not at the same time.
Yeah, you can insert more than one row at the same time. I could run multiple index programs, for example, from like block range 0 to 100, 100 to 200, 300 to 400, and they can all insert separately. So I'm finishing that index far quicker than if I had to go from 0 to 400 on one routine or one program. Yes.
In your role thing wider, is it just because of how the node was structured? Is there a potential for delay in your node getting?
Yeah, I mean, look, node providers are fantastic and highly professional. So you're going to get amazing service and you're not going to really experience much delays there. But you can set up your node in GCP and you should not really have too much more of a delay. The bigger risk with running your own node is if you make a mistake or you're missing a geth update, a lot of the manual stuff you have to do around managing your node is automatically done by node providers, while you have to take care of those operations yourself.
So I'm using Alchemy. It's obviously costly. I have my own node running, and I see some delay, especially
Okay. Mempool data, yes. Are you trying to do like arbitrage or something similar?
Testing or something else.
Okay. One thing that you can do is that you can run multiple nodes in different regions because the mempool is not necessarily synced between all nodes at the same time. So a popular setup is to run 3 or 4 nodes in different regions, and they'll have different peers. And then you can congregate that data yourself, like through another process, and that way you'll get a much more complete view of the mempool at like block execution time. Yes. Okay. How much? Sorry, I have like 5 more minutes. Anyone else? No? Okay, fantastic. Yeah, thank you for listening. Here are my details. Thank you. Here are my contact details. Please also grab me if you want my Telegram. I'm always free to chat, and I'll tweet out a. Oh, sorry. I can't control that. That's somebody else. I can just come grab me. I just need to get out of the way for the next presenter. Yeah, please just come grab me. I'll have the GitHub repo tweeted out. It'll have basically just plug and play for your indexer. Thank you, guys.
Check. Hey. You one is okay. Yeah. Test.
Hello, everyone. I think we're good to start. So welcome to the workshop, which title is Testing Smart Contracts with Waffle. My name is Bartek Rutkowski. I work for TrueFi, and I'm also one of the contributors to the Waffle open source library. And I'm going to take you through some of the key features of Waffle, and we're going to code some stuff together. So this is what we're going to start with, as the internet situation is not great. Everyone that want to go through the tasks with us, I recommend cloning the repository right now and going. So in the README, there is going to be a small section that's going to describe what you need to do. Basically, it's just installing the dependencies and doing some few basic steps. So yeah, I'm going to wait a second for everyone to do that. Okay, the URL is going to be visible also later on. So moving on, there are two basic approaches to testing smart contracts. One of which is testing smart contracts with other smart contracts, which has its very nice properties. But also the other approach is to test smart contracts with JavaScript or TypeScript code. And that's something that we're going to focus on. It has some nice things about it. So first of all, it's very easy and intuitive. So it is very fast, which is important if you want to test drive your code or if you want to make sure that the tests are being added to the code as it's being created all the time. It's also very, very flexible. I would say even more flexible than testing Solidity with other Solidity code. And it's also kind of DApp native in a sense that you interact with your smart contracts the same way your application is going to interact with your smart contracts later on. And then moving on to the Waffle itself, which is a library that utilizes JavaScript and TypeScript, it takes a very, very minimalistic approach. So it's not a very large framework that forces you to follow some certain rules, but it rather provides you with some set of utility functions that just help you with the largest pain points. Also, it's blazing fast, as for the JavaScript or TypeScript library, because some of the Solidity testing can be a little faster, but as for a TypeScript framework, it is extremely fast. It also has a very nice and friendly syntax, and it obviously is open source, so anyone having any issues or any problems can reach out, and also if anyone has any ideas what we can improve, then they are welcome to do so. And also, what is very important, that Waffle works well with Hardhat. So if you are already using your Hardhat setup, then you can use some of the features of Waffle as a plugin to your Hardhat setup. So you can use either Waffle standalone as a complete testing solution, or as a plugin to Hardhat, which is very nice as well. We're going to focus on using Waffle standalone, but recommend checking the documentation for the Hardhat integration as well. And what Waffle actually does, so it takes you through all the steps of smart contract development. So first, it helps you compile your code. Nevertheless, this is Viper of Solidity. For most people, it's probably going to be Solidity. If you are Team Vitalik and you prefer Viper, then yeah, you can use Viper as well. Then you can deploy your code, whether you want to actually prepare a deployment script for the mainnet or some other actually working network, or just deploy for the testing purposes, and then provides with all the testing utilities like matchers, fixtures, and smart contract mocks. I'm going to dive deeper into that later on. And what are the Waffle's components? It's TypeScript, obviously, with typechain. It's Mocha and Chai, which are JavaScript libraries for just JavaScript testing, but we utilize them here as well. And Ethers.js, which is a very nice library that wraps all the complexities of interacting with the Ethereum network. So now, what the whole process looks like. So first, we need our Solidity code. In this case, this is some Solidity file called exchange.sol, which is some smart contract. And then we need our configuration for Waffle. This configuration that we see here is not actually a needed configuration, because these are all the default values. So you don't need to create that configuration. You can just like skip completely this step. This step, but mentioning this if you wanna have something custom. And then we run a command, which is just invoking Waffle, and Waffle will produce the bytecode, the ABI, which is gonna be helpful when interacting with smart contracts, and a flattened code, which is helpful if you, for example, want to verify your code on Etherscan or a similar site. And then the smart contract deployment itself, which is extremely simple. So basically, you only need to import the artifact from the smart contract compilation, and then you need to use the deploy contract function. Super easy. First argument is who is deploying. Second argument is what is being deployed, and the third one are the arguments for the constructor of the function. Important thing to notice here is that the token object that we are creating here, which is the instantiation of the token, is tied to the wallet that deployed the contract. So whenever we're gonna be interacting with the token, we're gonna be interacting from the wallet. So the wallet is like the default sender of the transaction, and we can change that by just connecting the contract to some other wallet. So by invoking contract.connect, we can have some other person, some other wallet interacting with the contract. Thank you. I think I'm gonna find some charger, or someone will help me with that. Thank you, thank you very much. Yeah, that the computer is on low battery. Moving on. So now, interacting with the network. So there are basically three pieces of the interaction between the user and the network as a whole. So first we have our dapp, or a testing suite, or a script. And that dapp or whatever else uses a JSON RPC interface to interact with an Ethereum node, which is like one of the nodes from the Ethereum network. And we're gonna break down all these like three pieces, how sort of to wrap all that so it makes sense from the developer perspective. So first of all, we have the node. The node itself, usually instead of talking to the node or talking to the network, we use some API like Infura, Alchemy, Oct, or a default provider injected into the browser by the Metamask. But also we can use an emulated network like Ganache or a Bidler VM or whatever else that is just local instantiation that simulates the behavior of the Ethereum network. Or we can run our own Ethereum node and be the hero of the community, which I obviously recommend, but I understand this is not the case for each solution. And then when we have the JSON RPC level, we need to wrap the JSON RPC complexities with nicer functions. So we have two libraries, two major libraries that that help with that. One of them is ethers.js. Second one is web3.js. Actually, web3.js is older. Ethers is like the preferred one by me, myself, and a lot of my colleagues. But just to mention about that there are two of them at least. Yeah, and what ethers.js does is that basically it wraps the whole management of the keys. It helps you construct the transactions. So as we see here, we have the private key. Then from the private key, we can create a wallet object, and then we can add a provider of the network. So sort of connect the wallet to a link to the particular node, to the particular API of the Ethereum network. And then instead of just constructing some very bulky JSON and creating a HTTP request and sending that to the node, we can just use like a simple call like wallet.getBalance, and we'll get our balance. And the ethers.js also helps us override some additional properties of the transactions. So with ethers.js, we can not only construct like a basic transactions, but also override gas limit, nonce, value, chain ID, whatever else. And then if we construct the transaction, this is like the very bottom line, we can just add all these overrides and perform like a very custom transaction. And now we dive into the actual features of the waffle, because right now we are sort of discovering the whole environment that's around the core of the presentation and what waffle can do on the testing field. So first of all, we can have like basic testing. So we can just invoke some function, or we can have some value, and we can demand the equality. So first, equality, but it doesn't necessarily need to be equality. We can also expect the value to be within a range of some values, or to be close to some value, which is kind of dangerous, because obviously in the smart contracts we want everything to be super sharp and super precise. But in some cases, for example, if we are doing some calculations based on time, this is not going to be super precise, and you can use something like this. Then we can test all the events, and that sort of corresponds to what I was talking about when it comes to the DApp nativeness of JavaScript testing, because events are not crucial to the logic of the smart contracts themselves, but very often they are super important from the DApp standpoint, because we need to be notified about some certain action that happened, and we can test that very easily with Waffle by just expecting some transaction to emit an event with some arguments, or like emit multiple events or whatnot. We can also test external calls. So in this situation, this is a very simple thing, because we just call a function and then expect the function to be called. But we can have a very advanced use cases where we have like a contracts calling other contracts, and then we can check whether some particular contract within the whole call stack was called by some other contract with some particular arguments, which can be quite powerful and allows us to check some of the complex cases of many smart contract interactions. Then we have the reverts, which are also super cool to test. In my opinion, syntax is super cool, and which are obviously super important to test. So first, we can just test whether something is reverted, but we can also be very precise about the reverting reason. So what the error is. And also we can, which is one of the newest features, we can check the arguments of the revert. That's one of the newest features of the Solidity, and we have the reflection of that in Waffle as well. Then we have wrapper for the token balances, as this is something that we test very often. So we can check whether some transactions modifies balance of some tokens on some wallets. So we can do this for just one wallet, that we expect some transaction to modify the balance of a token, of a wallet, of particular value, or we can perform that for a pair of wallets, or a triple of wallets, or whatever else. We can also have mock contracts. So mock contracts are just like artificial things that pretend to be smart contracts. So we can set up a mock contract, deploy a mock contract, and then very easily define the behavior of the mock. So basically just say that mock, when called, when like a particular method on the mock is called, is going to behave in a certain way. So this is gonna return something or is gonna revert. We can also specify the arguments, and we can just basically model any behavior on the mock. And then the example of the usage of the mocks would be like this. So we have some setup that would return contract and a mock ERC20, and then the mock, we sort of like program the mock to return some value, and then we can, for example, check whether our contract correctly reacts to the value returned by the mock. So in the first case, that our contract, after examining the mock, will return false, or in the second case, it will return true, because the mock just returns some value that we expect or do not expect. And the last major feature are the fixtures. So this is an extremely powerful thing, because normally when we have like a set of tests, basically like a good rule of testing is that all the tests shouldn't depend on each other. So each test should have like a separated setup. We should be able to change the order of the test, and everything should still work. So basically what fixtures allow us is sort of reverting the state of the blockchain to some other state from the past. So basically we can perform some setup transactions, deploy some contracts, maybe perform some initial transactions, and then save that as a fixture, and then revoke the fixture in each test. So each test starts with the same state, and we do not need to redo all the transactions and perform all these transactions again. We just sort of point to that state in the past that we want to sort of start from this particular moment, and that actually is one of the things that make Waffle so fast, because yeah. And now this is going to be like a first full setup of the tests. So actually this is going to be shown also later on sort of a cheat sheet when you start coding. But here we can go through the whole thing. So first we need to import the stuff from Chai that we need. So we need the expect utility. That's as the most important thing. We need a type from ethers that defines contract, and then from Ethereum Waffle we want a deploy contract function. We want a mock provider function, which is the emulated network that we're going to be using instead of the actual Ethereum network in the tests, and a solidity, which is just an object that contains all the custom matchers. And then we import the contract itself. So we inject the solidity matchers into the Chai itself, and then we can start writing our tests. So here we can see that we create this provider. So we create this emulated virtual network. Then we create some wallets, in this case only one wallet, which is called Alice. We create some contract, and then before each setup, this time we are not using fixtures, we just deploy the contract, and then we can have like in this case, free tests that just assert some certain properties of the contract. Yeah, and now it's time to dive in. So we're gonna have two difficulty tracks. So first is gonna be like a beginner track. So you can use already done smart contract code that we have in the repository that you downloaded, or you can go through the advanced difficulty track. So basically start with an empty smart contract and test drive your code. So this is an interesting technique that instead of just writing the code and then testing whether the code is correct, you first write the test, see that the test is failing, so you make sure that the contract that you are testing does not have this particular property or this particular function, and then after you have the failing test, you implement the smart contract logic and then see the test passing. And then do necessary refactoring if you need, and then repeat. So go on to the next property of the contract that you wanna add. And what we are gonna be working on. So the first task is gonna be to create a very simple splitter smart contract. So a contract that is gonna have a split function, and when some if is gonna be sent to that function, while this function is being called, it's just gonna split the ether in half and send to different addresses, and it's gonna revert when the value of the if is gonna be 0, and if the value of the if is not divisible by 2, then we're just gonna refund the remainder to the original sender. And we want to write the test for that. And task number 2 which is there are going to be sort of actually quite a few of them, and you can do them in any order. So first, at the proper event when the split happens, so just signalize that the split was called with a particular result. We also want to signalize whenever the non-zero remainder was returned, because because we have that function as well, and we also want the owner to be the only person that is allowed to use the contract. So the split is going to have a restriction that there is only one owner who can split the ether using the contract. And then we can also use a dynamic array of addresses. So maybe these are not going to be set for good in the smart contract, but they are going to be arguments to the function, and maybe we're going to have like more addresses than 2, maybe 3. Or 4, or just a dynamic number of them. And of course, we want to create tests for that. So that's like a cheat sheet that I'm going to stop on. So first QR code that you have is a waffle documentation that should help you with everything. The bottom QR code is the repository that we are going to be working on. On the left, you see the list of the tasks that are to be done. And on the right, you have a sort of a basic template that shows you what's the general idea of the test and how they more or less should look like. Yeah. So if you have any questions, or if you need to, or you need help with something, then feel free to reach out. I'm not the only person here to help. I have Daniel, Przemek, and Justyna from my team here as well. So if you have any problems or any questions, we're here to help you. Okay, should I add something? Yeah, so are there any questions? Do I need to repeat anything? Is everything clear? Okay. By the way, question. Were you guys able to download the repository? Because the internet situation is not great. So if anyone was downloading, yeah, okay. I see some thumbs up. So I guess there was a success. Okay, cool. Hmm? Oh, that's a good point. So actually, I'm gonna switch from the presentation. Oh, nice. So here's the repository. This is what it looks like. So the first thing is the contracts folder. Here there is the Ether splitter, the empty one. So if you go for the Solidity implementation yourself, then you should start your work here. If you want to use the already created contract, it's gonna be here, the Ether splitter ready, with the split function. It doesn't have all the features from the task 2. You can add them later on. And then the test section. So first, some reference in the templates file, and the tests themselves should go into the Ether splitter .tests, where everything is set up. And here you can also see that we use Ether splitter. So we import the empty Ether splitter. If you want to use the already created one, you should just swap the name here from Ether splitter to Ether splitter ready, which basically would be just uncommenting this line and then commenting this one, and that would make the change for you. Okay. Yeah, readme, that makes sense. So actually, I'm gonna. Okay, so first of all, you need to have the node installed, and which I would guess that most of us, you should have that installed already. Then you will need yarn to install the repository. If you don't have it, then here's command for you to run. So install yarn, and then cloning the repository. entering the repository directory, installing the repository, and then the two commands that you're going to be using more frequently, yarn build compiles the code, and yarn test runs proper tests. Yeah, and also some documentations link if you need something. Okay, so I think we're gonna give you some time now, and actually, I think in a few minutes maybe we're gonna do some live coding if someone's gonna be lost, and show you some of the things that are here. But yeah, but for now, giving you some time.
So if you have questions, just raise your hand. We'll come to you.
Yeah, that might take a little time, unfortunately. Like with NPM, it would be the same, but yeah, I hope it's gonna like take a minute or two, and then it's gonna install everything and. Oh, there's a question here. Maybe someone can go and help a bit. By the way, in the meantime, as we are waiting for the repositories for everyone to install, have you guys used Waffle before, or some other testing library? What you've been using? I'm just out of curiosity if you've been using anything. Cool.
You can use Waffle as the plugin.
Yeah.
Yeah.
So the only difficulty of the point was that there's no, I would use a Foundry and that, and a Foundry of all and on the when you compare that, it's no problem. So I think that kind of having on different environment is really cool. So I think that the kinds of integrated
Yeah, I absolutely agree. So the testing frameworks like Foundry, it's super easy to test, like you to do like unit tests, which of course you need to do this, but at the end of the day, you want to have like a very complicated interactions and maybe multiple calls, multiple transactions, so on and so forth. And it's easier to do that with Hardcut or Waffle. Yeah, so sort of like from outside of the Solidity itself.
Methodology or concept model that web has.
I'm gonna go closer.
Okay, so do you have any kinds of opinions on
Anto.
Web3 style
So okay, so I'm Jen. I don't know. There's a kind of panel stuff like that. Anyhow,
Apparently.
yeah. Since I'm just waiting for installing the dependency. So
Yeah.
anyhow, yeah, well, I'm really interested in writing some tests, and when it comes to Web 2, there are tons of the methodologies and the tips for writing tests, right? So for example, is writing kind of given when then pattern, or kind of or BDD, or the behavior driven test, or that kind of things. So that kinds of things in Web 2. So when it comes to Web 3, it seems like the security is also important. So I think that the mental model for testing in the Web 3 world is really important. So I think so I really wonder you guys are thought in the testing, especially in the Web 3 world.
Yeah, absolutely. So I think that one super important technique and sort of like mental model around like not only testing but developing smart contract as a whole is that test-driven development. Because like when you're like writing so I'm actually maybe gonna stand up. So if you're writing a Solidity code, it's super important that the contract actually does what it needs to do. So that you don't have some unnecessary lines, that you don't have any things that were put somewhere and you thought that they're gonna be useful, but then at the end of the day they ended up being not useful. That all like costs gas, and this is all like a bloat that needs to be reduced. So it's so a very nice technique is to actually test drive your contract. So actually write a very explicit expectations about your code and define what behavior you want to achieve from the contract, and then implement only the code that sort of like performs the logic that is required um, to fulfill the sort of to make the test pass. Yeah, and then you need to go like through the whole stack. So there is sort of no differentiation like whether you should use unit tests or integration tests or some other type of tests. You probably need to use like all of them. So like it's the easiest to just test drive your code using unit tests. So these are gonna be the tests that you're gonna be writing, like most of the time. And then if you like test drive all the functions, test drive all the like small bits of the logic that you need to put in place, then you probably want to move on to the integration tests and see how larger transactions, how like more complex cases resolve, how performing multiple transactions in a row affects the state, and sort of like how this whole thing behaves. And that's sort of also not the end of the story, because then you need to have like the whole, or you should have the whole like testnet deployment. You should play around with the whole thing. You need to you also probably should develop like the app or the script that is meant to interact with the smart contracts in parallel to the smart contracts themselves, so all of like these two like remain in sync. Yeah, I don't know if there are any other tips that I can think of. Maybe someone can add something. Okay, actually, maybe someone has any more questions. And yeah, oh yeah, the microphone is coming.
Is there Viper support?
Yes. So basically, the only thing that so on for Waffle, the only thing that's is different for Waffle and the Viper is that you just need a different compiler, and then you basically end up with like the very same compilation products. Which one is like the bytecode that's just gonna go straight to the chain, and the ABI. And all the abstraction of like wrapping the calls with like ethers.js is also like the same for Viper and Solidity. So yes, definitely there is Viper support. You just need to use a different compiler, which is also like I think you need to specify in the Waffle config that you are compiling not Solidity but you are compiling Viper. Well, that should be it. I'm pretty sure this is somewhere in the documentation. I don't use Viper personally, so I'm not very familiar with that setup. But yes, Viper is definitely supported.
So can you also expand the discussion about testing in Solidity and testing outside Solidity? Because that's kind of a hot topic with other frameworks like Foundry that they use Solidity, and they have limitations or things that are that need to be worked around it. What is your view on this?
Sure. So actually, I think that the main advantage of using solidity testing is the fact. So there are two things. Okay, one is the pace. So testing in solidity is definitely faster, and just having everything inside of the EVM just makes the test run faster. So which might be important for some people, and it is sometimes actually important if you want to, like run the tests very frequently, which makes sense, and you should do that. So this is a nice property. But then, like if you have like some continuous integration system on your repository, then it's probably not that important because even like the JavaScript tests are not gonna be that long. So that's one thing which is just the performance, which is better on the Solidity side, and the other is the fact that when using like TypeScript or JavaScript tests, there is this JSON RPC middleman, and there is also like casting of all of the types. So for example, when you call a function and then something is being returned, this is like some JSON, and the big number that's being returned from the Solidity or Viper code is just a very large number that's not able, that JavaScript is not able to process. So you need to cast it, you need to have special types, and there were times when it was actually a problem that we didn't have like a good implementations of big numbers, and some people were just casting to strings, then comparing strings, and this wasn't great. But now I think that it's not that much of a problem anymore. Of course, like you have all the native types and native type compatibility within the Solidity itself. And while using JavaScript with TypeScript, this is sort of external and you need some casting, so on and so forth. But I think this is not that big of a problem. I think at the end of the day, the bigger difference is like sort of collapse to what you just prefer from the sort of developer experience standpoint, because I truly believe that both of these approaches can be just very precise and can really clean your code from any bugs or any errors, and are just like both very good. Yeah.
Along the same lines that I'll talk about is have you yourself or seen instances where you're actually testing the user interface? So you're basically doing the same UI testing you do with Web2 via Selenium, and then actually kind of dropping down into Solidity by executing it, for example, through a browser?
Yeah, actually, yes. I think I haven't been reading this kind of tests myself, but we definitely still do test our front ends with a typical like Web 2 tools that even just like display the whole thing and then like click into like the particular, like virtually like click into like the particular sort of components, and yes, and actually perform transactions. Though in this case we would need something that would just work very fast. So we, as a Ethereum network, we wouldn't use like a testnet or a mainnet, of course, but just an emulated network. Yeah, Przemek,
yeah, I might try to expand. So we, what we do in TrueFi, we run the whole local blockchain with Ganache or Hardhat. We also run a local degraph, and then we run the front end and click through the front end, sending the transaction through Metamask on this local network. So this is what we do, but it's separate from Waffle, right?
Okay.
Hey guys, did you manage to download and install Yarn, build, etc.? Yes, you did? And how is it going? We failed. Yeah, so my proposition is we are going to plug in a different computer and live code with you. And if you didn't manage to download it, you can come here and like we can do it together. So it's more interesting. And some people don't have computers, so you can do it with us here. How does it sound? Great. Yeah, so let's start.
Okay, so I'm swapping the HDMI to some other computer, and we're gonna live code.
Yeah, and let's start with this task 1, and Przemek will.
You understand?
Yes.
All right, guys. So, do we have volunteer to start the first task? We'll go the harder track. Yeah. So come here and big round of applause for our volunteer. No. This one.
Oh, okay.
Yes. So task 1 is we have empty contract, empty test, and we're starting with writing test for one like functionality of the contract. Then we write the function in the smart contract, and then the test should pass.
I can help you. Help me around some.
So some technical problems. Give us 1 second.
So we're basically going to mob now.
Yes, pair programming for now, but yeah, mob.
Maybe let's remind the exercise, the task.
Yes, so we want to write ether splitter.
So just a simple exercise. We take an ether value to the function of a smart contract and divide it into 2 addresses and make sure to return the remainder if it's an odd value. So just something simple.
Hey guys, can you see the text? Great.
So we need to add another set of another each statement. And it will test the splitter function, right?
Okay, so we are going to start from the first test.
Which contract is it? Ether splitter or the ready one? You just want to see how the function looks like.
Right now it's ether splitter and it's empty.
I guess we just have to call the sorry, this is called ether splitter.
We have an instance of splitter below. So take a look at line 30, 31.
Oh, right.
Yeah, there's
So
splitter
one,
already
right?
deployed. There are addresses to be used. Yeah, we have an instance of splitter, and we have some accounts like Alice, Bob, Charlie, and David.
And we have to catch the value, right? Does it return something?
No, it doesn't. So you want to test the balances of the accounts before and after.
Something's wrong there. Why?
Yeah, because right now you use the ether splitter, which is not implemented. Take a look at the contract right here. This one. Yeah, right now we use this, which is not implemented yet. Do you want to implement this, or do you want to use the implemented one?
Let's implement it.
Okay.
Yeah, so that's normal. That's when we do like TDD, like test-driven development, and we want to call some function and see the results of the function. Then we just have like an error, and we need to first create a signature of the function.
Just split the message.
Let's start with just the function. Let's make the test pass, maybe. Let's build.
Skip the return, just make it public.
Public. What else?
Looks nice. We can save it and then build, right? And then run our tests, see that it works.
If you yarn build, then
Yeah, so we need to run yarn build in terminal. So can you please? And probably
just yarn build.
Yeah, here we use yarn.
Yeah,
so
yarn.
yarn build. So now we are compiling our Spark contracts with Waffle and could generate types with type chain. And now we can run yarn test to see that our tests are passing. Let's see. Yeah, for now, great. It works. So now maybe here we have like this split. And now what we want to see? We want to see that as a result of split, some balances will change. So what should we put here? We have what addresses we have.
We can use Charlie and David as those two receivers.
We have Charlie and David. These are like random addresses. And as I understand, we want them to get, let's say, let's send one ether to splitter, and then expect these two addresses to just get.
Can I? So maybe let's expect what is before. So let's say that. Yeah, so I test that Charlie and maybe David have 0 before.
So maybe let's start with just one address, just Charlie. Okay, so we can do like proper TDD, which is just start with simple example and then go to more advanced ones. So right now, what we want to do is to first check that the initial balance is equal 0, then call this splitter and split, and then let's expect, for example, this balance to be equal 1.
Yeah. Or let's be 10 into 5 and 5.
Right.
Okay.
With just one, right?
Yeah, I'm gonna instance a big number for that expresses one token. So one token. Not used to it. Okay.
You will need to import big number. Oh, okay, it's.
Yeah, there it is.
Actually, you don't need big number. You can do it differently. You can use properties of ethers. You can call. No, not like this. You can leave it. Can I show you?
Okay, yeah, show me please.
So we can not like this format. I always format 1. Let's import ethers, and now one token should be 1 ether, right? But you probably want to move it higher, so you can use it in this split function.
All right.
Maybe it could have.
1 second, because we want to pass this as a value. So these are those overrides.
Oh, right.
Yeah, and this will be this value.
The function doesn't receive any.
Yeah. So this will be this message value, and okay. And what do you expect? Next one.
If this is an ether's instance, maybe we can just divide by.
No, let's start with 1. Just one address. Let's not split it. Let's just
Okay.
do it 1.
And it should pass.
Right.
Okay, our terminal is broken. Our Visual Studio Code is broken. Yes?
Mike?
Okay, it doesn't expect that. What if I try to do this?
No, it's not format ether, it's parse ether.
Parse ether.
I always confuse these two.
Alright. Is it complaining?
Or should I come to you?
Is it not value? Why is it complaining?
Payable. Oh yeah, yeah. It's because it's not payable in the actual
it needs to
code,
be
Solidity
payable.
code.
Yeah.
Yeah.
Yeah,
So
yeah, yeah.
make it payable.
Good catch.
This is TDD.
Ah, yeah.
Okay,
Right.
you need to build.
We're using actual TDD.
You need to build because we changed the smart contract, so we need to build it and then test it. That's,
Okay.
sorry.
I'm used to use it alongside hard hat, so it's just one command. But
okay. Yeah, good. We're on a red test, so now we can implement it.
Nice.
Okay. Do you want to break
0.
or do you want to continue?
Let's continue.
Okay. Yeah.
Let's go on. So we should.
Yeah, so we need those two addresses, so you can either take them in the sprint function or take them in the constructor. Yeah. The two addresses that will be splitting.
We're gonna hard code them.
Yeah, let's hard code them. Let's keep it simple because we only have
right.
10 minutes. So just
it was
simple,
Charlie and Bob.
Yeah, or
Bob and Charlie,
or receiver 1 or receiver 2. Yeah, I can do.
Thank you.
You need to set the properties first, right? We're gonna take the two addresses that we split in the constructor. Address payable. Just underscore address 1. Wait, no. Let's do it like this. Like this, right? And then this is it. And then this is this. Yeah, so we have a constructor with two addresses and we'll be splitting the funds into those two. Maybe you can start implementing the split right away. We have the message value, so we'll do address 1 that's transfer or send. The message value is the amount that was transferred through the payable function. Yeah, and gently test. Yeah. So this will be half of it, right? Only 2? Okay. Okay, what's going on? Yeah. Let's run. Okay. Our code is has hang again. Not yet, but it's hanging. So we don't have a lot of time, but if anyone would like to continue, we'll hang around somewhere here. We can help. Shit. It's frozen.
Shit happens. Dobra. Okay, guys, we need to finish. So we didn't manage to do a lot within a short period of time and not very perfect internet situation. But if any one of you wants to continue, then we are here like outside of the room, and we have our booth. So you can drop by, we can talk, and we can help you to continue with everything. So yeah, thanks a lot, and see you around at Devcon.
Can everyone hear me okay? Yes, that sounds good. All right. Hello, everyone. I'm Eric Marks. I am the lead engineer of Metamask Snaps. This workshop is called Getting Started with Metamask Snaps. I realize we have some Wi-Fi issue since 2018. Snaps was first announced as a concept 3 years ago at Devcon in Osaka. So I know we have some returning guests with us today in the room, and since then lots of things happened. COVID happened, 2020 happened, but since 2021 we've been working on Snaps full time at MetaMask, and since the beginning of this year we have been in a developer release via our Canary version of the MetaMask extension called MetaMask Flask. This workshop is basically like the sort of Snaps 101. How do you get started like developing a snap using one of the newer APIs that we developed? If you read the instructions, there's a custom build of MetaMask to download because we haven't shipped this API in production yet. It's coming in the next few weeks. Before continuing, we need to talk a little bit about what is MetaMask Snaps. And we're gonna start from the very ground level and build up from there. And so MetaMask, as all of you probably know, is a non-custodial cryptocurrency wallet for Ethereum. You enter your secret recovery phrase into MetaMask. You can derive your keys in your externally owned accounts, and it will manage those keys for you, encrypt them with a password. MetaMask allows you to interact with Ethereum via an RPC endpoint. By default, we use our friends at Infura, but you can add whichever ones that you want. And that allows you to do stuff like send transactions from account 1 to account 2. The really powerful thing about MetaMask is that it enables you to interact with Ethereum dapps. And so that is through our window.ethereum provider object that we inject into the web page. And that is what all dapps use in order to submit JSON RPC requests that are either handled directly by MetaMask or smart contract accounts. What about zero knowledge applications and non-Ethereum cryptography, so like things that use curves other than SecP 256K1, and that's just like a sample of the things that's being built in Ethereum that we don't support out of the box, and that doesn't even get into Cosmos, Polkadot, Avalanche, Solana, whatever. In addition to those things, and so it is we believe basically impossible, and I think practically like empiric, like I observe this, I don't predict it. It is impossible for any single organization to add support, to develop the domain expertise to understand all of these different protocols and primitives, and then also to develop the code and maintain the unimaginably large code base that it would take to actually create user experience for all of the things that are being built in Web3. And MetaMask Snaps is our answer to this problem. And snaps are simply sandbox programs that are run by MetaMask, and their purpose is to create new user experiences in the wallet. And that is to say, the purpose is for them to modify the wallet in some useful way. And the user adds snaps to the wallet at runtime, and they have access to special permissions that are not available to dapps, including things like key management, and that makes them uniquely powerful building blocks for Web3 developers. And so using this simple model, just in the past week, over the course of ETH Bogotá and a hacker house that we co-sponsored with BitDAO and Game 7, hackers have developed a CK nullifier snap, a transaction security snap, an account activity notifications, and a smart contract account wallet, or a smart contract account support, all in MetaMask, all using snaps. And snaps currently in developer releases include Starknet, Filecoin, Bitcoin, Arweave, and many more. And so And here I'll just briefly stop to say that like we're all like this isn't a developer release, so the reason we keep it in a channel is because we don't. It's not quite ready to be pushed to you know, the tens of millions of people that use MetaMask on a daily basis. But that is our goal in the upcoming year, and we'll get to that in a bit. And so we believe that this illustrates that Snaps is the gateway to all of Web3. By turning the wallet itself into an application platform, only then can we invite the entire community in order to bring their domain expertise and their passion for the specific features and functionality that they're interested in order to add that functionality to the wallet and make it available to all of their users. And with that, we're going to get started. So again, there's the HackMD link for those of you who are able to access that. And we're going to start here. And we're actually going to. I was too busy trying to get my Wi-Fi to work to clear out all of this stuff, but we'll get started here in a second. And so as I mentioned, the first thing that we need to do is add a custom build of MetaMask Flask to the browser. And my visibility is the size of like the editor and the text and everything good so far? Okay, yeah, please holler at me if not. And the way you add a custom build to Chrome is you simply get your build from wherever that lives, and you just drag and drop it in. Your browser needs to be in developer mode in order for that to work. And be advised that developer mode like exposes your extensions to certain kinds of malware. So you know, don't put main in developer mode. And we're just going to go through onboarding here super quickly. I'm going to go ahead and snag my throwaway seed phrase for that. And Wi-Fi permitting, we should be good to go. Okay, yes. All right, so now I've set up a version of Flask, and so the only thing you'll notice that's like immediately different with Flask is that the onboarding is slightly different, and we have a purple fox to distinguish it from the regular orange fox. And the next thing we're going to do is, I've already done this, but the next step is to create a new GitHub repository using the template snap monorepo. So this monorepo is a template that contains two things: two sub-repositories or packages, a website, and the actual snap itself. And things are they're kind of loading. But once you've pulled that down and run yarn install, we can see here that should still be good. That we have in our packages. We have the website and the snap. And I'm just going to make sure that we've installed and everything with that is good. And then we're going to kick things off by running yarn start, which should hopefully not need too much network access. Great. And so this is the template snap interface. And so you see we have everything hosted on localhost. And the first thing we need to do is connect to our snap. And so first, when you install a snap, you get a permission request from the website that made the request. And it's basically saying, hey, the website at this URL wants to talk to this particular snap. And during local development, snaps are just identified by the localhost URL where they're hosted, just out of convenience. And once we've accepted that permission request, then MetaMask will go and fetch the snap source code and its manifest, and then ask for its permissions. And so here we see that this snap, again identified by its localhost URL, wants to display confirmations inside of MetaMask. And we're going to say OK to that. And to try out this functionality, Whoops. Excellent. Ah, something. Maybe I waited too long. It wouldn't be a workshop or a demo if everything just worked out of the box. Okay. Now it's claiming that everything is fine. No metrics. No metrics. It won't work anyway. Okay, now. Yeah, I'm suspecting that this is a network issue because this was not happening when I tried this at my hotel mere moments ago. What, in this terminal?
Yeah, in the terminal in general, like so they're running the same thing. So we're trying
Okay. All right, so it failed to add it. Pretty please. If someone has a tether that works and you're feeling charitable, we're gonna try something from scratch. Yes, please do talk amongst yourselves. I'll try Devcon Workshop maybe. Okay, you do it.
The local prefix is supposed to be there. I also have the extensions.
Yeah, well, one's disabled, so that shouldn't be the problem. Yeah, this setup was. Okay. All right, let's see if that works. Okay, this is good. Okay, we're gonna give it another try. And let's see, we don't have any crazy errors in here. That's fine. Okay, all of that looks good. No, I have a bad state. Okay, we're quickly going to add this back. And that's fine. And that's fine. And that's fine. And that's fine. Cool. Boom.
I have the same error.
If you want, I have a snap run.
Wait, ooh. That's it, folks. A snap, everyone. Get a look. It's showing a confirmation. Oh, goodness. Yes. Okay, it's real. Yeah. So what happened here is I was going to mess around with this notification a little bit, but or confirmation rather, but we're not going to do that. So this is just a dummy notification for display purposes, and we're going to skip right to the source code and look at like what is going on and what is the anatomy of these things. And we're going to reject that, and that's totally fine. And so if we go in back here, and if we look at, let's see, we have packages snap, we have like in the snap package, there's like some regular like npm stuff JavaScript stuff going on, but you also see that we have a snap config and a snap manifest, and then a source file, and then the source file is just index.ts. And so looking at the manifest here, you're going to see that there's a version, which you may have noticed matched what we saw in the application. And then we have some information about the source, so a SHA-SUM of the bundle, and some other like metadata if we were to publish the snap to npm, which is our currently supported like distribution mechanism. We have plans for others. And then finally, you have the permissions here. And snap confirm is the actual RPC method that gets called by the snap in order to display a confirmation inside of Metamask. And if we actually look at the snap source code, you see here that it exports this on RPC request handler function. And basically the way that looks from inside of the website, so this is a file from inside of the website, you will call this, it's an RPC method inside of an RPC method. So you have wallet invoke snap, and then you pass it the ID of the snap and then the request that you want to pass to it. And you see that the method is hello. If we go back to the snap, that is the only method that we support, and that just causes this confirmation to be displayed. Now, if things like continue working a little bit better than they were doing some minutes ago, we're going to take this snap and turn it into a transaction insight snap. And if we briefly return here, so we've demonstrated like we've gotten a snap running, and now it's time to like replace its confirmation permission with this transaction insight permission. And all that this permission does is it tells Metamask that like, oh, this snap wants to provide transaction insights. And in order to do so, we're just going to nuke the contents of this file. And then we're going to go ahead and import some other stuff, namely on transaction handler. We are going to add a package called utils, and we're going to import some stuff from that. And then we have this handler that we need to specify on transaction. And that is going to be a function that looks something like this. And right now it's a sad function because it's not returning what it needs to return to satisfy its type. And we're just going to return some like dummy, a dummy insight for now. Oh, and I think we also need it to be async. Yes. Okay. And we're also just going to add a little bit of validation to make sure that the transaction is of a type that we can understand, because like, you know, we're writing a specific insight snap that uses our particular domain knowledge. And so we need the transaction to look a particular way. So if it's not an object or if it doesn't have the property data, or if the data is not a string, then we're going to say, oh, actually, we're going to do this first. Oh, wait, no. Just going to call it an unknown transaction for now. And then we're going to say, we're going to import this. We're going to import this. A little warning for sanity in case I make any typos here. Perfect. And then we're just going to do this down here. And we're going to hide that. And then we need to make some modifications on the front end as well. And on the front end, so the front end is just a React application written in TypeScript, nothing fancy going on there, although it certainly looks fancy. And I'm going to snag a little snippet here with some useful constants that we are going to use, because right now our problem is that, let's see, where do we have send hello? When we click on the on this button here, it is going to call this handler, which is going to call send hello, which calls this hello method. And we don't even have an RPC handler anymore, so that's not going to work. So we need to delete that, delete this, and then rather than doing that, we're first going to grab some accounts because we need access to the user's accounts in order to send a transaction.
You need no wait.
I do need an await. Thank you, sir. And then if there's no account, we're just going to throw an error saying failed to get accounts. Actually, that should even request if it rejects, but you know, never hurts to be defensive. And then once we have done that, we are going to, then we have an account, and then we're going to just send a transaction. And we're going to do, again, method eth send transaction. And we're going to have some params that should be recognizable to many of the fine folks in this room. So we have a from address. The to address is going to be the address of a contract that is in fact deployed to mainnet, but that will reject any transaction that we accidentally send to it. I just happen to know this to be the case. We are not sending it anything in terms of value. And then the data that we're going to send it to start with is just going to be some dummy like 0x1. And that is basically, oh, right. And now we're going to have, now I'm going to have a little fight with Prettier. For some reason, the ESLint Prettier plugin does not work as advertised. We're not going to let that stop us. Haha. Excellent. Okay. Now I'm going to try to reconnect, and it's not going to fail to install. And so we can see that like the permissions that we're requesting have changed because we're now fetching and displaying transaction insights. That's the purpose of the snap now. We're going to improve and install. And I'm going to anxiously look at the background console. I think it worked. Yes, it did. So now it's asking for accounts. That should be familiar. And here, where Metamask is trying to estimate some stuff. And look, foobar. Okay, we're using the API correctly. We're slowly inching towards our goal. You're too kind. You're too kind. All right, and so we rejected that, and there's an error here. That's totally fine. That's expected. We love our expected errors. Okay, so the next thing, so the front end now for like this demonstration is basically done, and we're gonna go back and look at our snap, because the next thing is, okay, so we managed to like interact with the API. We've demonstrated that we can do transaction insights, but now let's actually go get some like useful information and see if we can like decode more of this transaction than we're currently doing. And in order to do that, we're going to add a second permission, because we are going to call the 4-byte registry API. And snaps do not get network access by default. So they cannot just like call out to the network unless they are granted the permission to do so explicitly. And that permission is simply called endowment network access. And we are going to call, as I said, the 4-byte API. And we have some useful snippets here in order to do that. And so here, this API endpoint, that's simply just like the 4-byte API endpoint that we're going to call. It has a single query parameter, which is the hexadecimal like 4-byte signature of the contract call data. And then we have just a useful type that we will use when we parse the results once we get them, this network permitting. And so, actually, before I forget to do this, I'm going to swap out this dummy value into something real. Let's see, transaction constants dot update withdrawal account. So these are just like some encoded contract calls that to save time, we encoded before this workshop. And so next we want to fetch data from 4-byte, and that is going to start with a fetch call. Await, fetch, or wait, are we done? No, we're not done, because we need to parse the transaction data first. And we are going to do, let's see, function signature is going to be equal to, all right, first we're going to do transaction data actually, equals remove 0x. So we're going to, it's 0x prefixed, and we're going to strip that. Excellent. And then the function signature is going to be the first 8 bytes of the transaction data, or sorry, the first 4 bytes, which will, let's see, transaction data dot slice. There we go. And now we have the function signature as well. And in order to fetch from 4-byte, we need to do the API endpoint followed by the function signature with a 0x prefix. And then we have some parameters to give this, which is going to be get. And we have just some basic headers. I would already knew what I was going to do. Boom. Sweet. And then if we failed to do that, we are going to throw, and we're going to say, failed to fetch from 4-byte registry. But otherwise, we should be good to start working with this data. And the result is going to look something like this, where we get the JSON. Oops. And that's going to be a 4-byte signature, an array of 4-byte signature results. And then once we have that result, so there's one thing we have to deal with. We're going to extract the actual text signature of the function call. Because 4 bytes is not a very big space, there are a lot of collisions, so it might return multiple results. Anyone who's dealt with this with 4-byte in practice is probably familiar with this problem. And we're just going to pick the oldest one because we need to pick something. And so we're going to see function text signature is going to be, let's see, result. And then we're going to sort created at locale compare b dot created at. And then we're just going to map that to value dot text signature. And so, and if there is no function text signature, then there is no signature for this. And so we're going to say no function signature or no function, no results in registry for function signature. And then we're going to do an early return. But in the happy case, we are going to have our insights dot type. And we are going to give that a try next. And we're actually going to lint as well, just to ensure we have no problems with that. Okay. So going back, we're going to need to reconnect because we modified the snap. The live reload, unfortunately, doesn't go all the way into the extension. Someday, we're going to be able to do that. But now we see that the permissions are different. We have access to the internet as one of the permissions now. And we're going to go ahead and approve and install. So far, so good. And then let's see what happens now. Ooh. This may be a lot to ask of the network at the moment. Yeah. The console does get the console there is, we probably have a bug where there is too much looping happening in the background. But if I reject this, I might get a useful, aha, okay, yeah, so I messed it up. And let's see what I messed up. Yeah. No, the thing that was result is the thing that was undefined. And that hasn't happened before. I shouldn't. No. All right. I'm going to cheat. Let's see. Oh. Ah. Thank you. Thank you, eagle-eyed stranger. Yeah, if I were, if I had done my types better, this wouldn't have been a problem. Would that be a lesson to everyone? Okay, now we're going to try that again. Hey, there it is. There it is. The function signature. The function signature. And for our final trick, we're going to get a little bit fancier. We're also going to decode the actual parameters that are encoded in the call data as well, just because we can. And in order to do that, we are going to add another package called ABI utils to our snap. Ooh, spooky workshop. And that's too much. Yeah. Well, we'll let someone will no doubt figure out the right level. And we have another snippet. Hey. If we increase the frequency there a little bit, like we can really create magic in here. And so this, this ABI utils package has an encode and a decode function, which allows you to decode and encode call data, and it has it returns values that are not JSON serializable. And that doesn't work because the transaction insights need to be JSON serializable. So this is just a function that handles that, and we're not going to worry about what it does in detail. Decode parameters. And so we are going to import encode from Metamask ABI utils. Stupendous. And for this one, we need to do some slicing. Because first we need to extract the actual parameter types from the function text signature, and we're going to do that by some good old-fashioned string parsing. And so we are going to do function text signature, and it's going to be a slice, and it's going to be an index of the first parenthesis plus 1. My ID is leaking that I've already done this earlier today. And then we are going to split. Right, because if you'll recall that this looks something like function name type 1, comma, type 2, ... So we're just going to extract this substring, split on the commas, and then we're going to have the parameter types. And the reason we need that is because that is an input to the decode function. So then we are going to decode the, let's see, parameter types. Let's see, const decoded equals, and let's see, the next thing I want is, yes, now I want the transaction data without the function signature. And why wouldn't that work? Oh. No. Great. Okay. And so that's going to give us the decoded stuff. And we're going to decode the parameter types out of the transaction call data. And just to make sure, I'm going to cheat again really quickly. Normally, I would have my notes off to the side so you wouldn't know that I'm cheating. But life is not fair sometimes. And then we're going to set insights.params to decoded. We're going to map that with our value normalizer. And then we should be, now we should be in good shape. Ooh. Oh, I don't want encode, I just want decode. All right. Now we're going to reconnect again so that Metamask loads our changes. We're going to send a message. We're going to open this up. Hey, parameters, address and Boolean, just as we would expect from the function type. And so now, this is, so obviously like we're not going super deep and like just seeing the parameters here is not super useful, but the point that we're illustrating here is that like, you know, this snap is pretty much, aside from hitting 4-byte, like it's self-contained. It uses like very basic like utilities in order to like tell useful information. And obviously we could dig deeper into the call data if if we wanted to, or like fetch, you know, the compiled contract code and try to like say something about that. And so I mentioned one of the snaps that got built at the hackathon recently, and we've had a couple of these built so far by the community, which is just like snaps that do, they know something about contract security or have like a list of accounts or addresses that are unsafe. And will display some information to the user when they're like, hey, like this isn't going to work. And you could just as easily imagine, like you could even run ganache inside of a snap in order to simulate the transaction, or like hit a tenderly endpoint or whatever like service that you imagine in order to add like useful data that you know about and that MetaMask does not know about for any given contract interaction. And that is a wrap for the workshop, and I am happy to take questions for the remaining time that we have. Cool. And you were fast.
First? Oh, cool. So I really like it, and I can definitely see a lot of use cases where I would use it. My only concern is that I often have to support other wallets. So, for instance, if Coinbase wallet, which to be honest I don't like as much because it's not open source. So, would it be possible, or do you see other wallets implementing anything like this, or do you see any support from like other tooling? You know, the community uses like Ethers or Wasabi to support this, or maybe in a way that if I'm in MetaMask, I have a snap, but in other places it's not broken.
Right, right. And so so we are trying to create specifications for like the manifest and the APIs that we ship and so on. We have a lot of work that I won't have time in progress that I won't have time to talk about. But like using something like Wallet Connect V2 to like, you know, just like the dApp will just ask for the network that it wants, and then MetaMask will go and find the snap that supports it and add it as part of like the connection flow. So you don't have to like call a specific snap in order to interact with it. And so we're trying to create specifications for those things. And I can't talk like really about concrete plans at this point, but personally, like I would love to see snaps become like an open standard, and like for there to be like an open source like wallet kernel or something that like others can build on in the future. Yeah.
Nice, thank you.
Sure. And I think I saw you next.
Are those snaps website specific? Like, can I just deploy it from anybody can download it and use it?
Yes. Yes. Correct.
How does that work? Is there
there is no marketplace as yet. If anyone wants to build a marketplace, we would love to see that being built, because we don't want to have an app store We want it to be like a full and open permissionless ecosystem. And so right now, the way it works is like when a snap is published to NPM, like if you have MetaMask Flask, you can install and run that snap, and any website that like knows how to talk to it can talk to it. And once we get to stable, we're gonna have like essentially like a block list if like there are known malicious snaps and things of that nature. But really, in order for this to scale, there is going to need to be like a Yelp for snaps, essentially, in order for people to like be able to establish trust in them, because we do not want to be in the business of running an app store, because it's antithetical to the values of Web3, and also it sucks as a job. Does that answer your question? Splendid. And I think you were next also.
My main concern, I think, is a very issue, but how do you think it's going to prevent scams?
Yes. Yes. So that's like so. Recently, if you follow like news about app stores and stuff, there was an instance where like there are essentially two philosophies that you can use to approach it, like the sort of walled garden app store approach that exists right now, and what we want to do, which is a permissionless web of trust model. And so in the app store model, it basically relies on like executive oversight and like review of the tenders of the walled garden, like for scams to not be presented. But like just the other week, I think Facebook reported to Google a list of like hundreds of malicious Android apps whose only purpose was to steal Facebook credentials. And so even like with executive and oversight, like it's impossible to fully prevent scams. And I think the best way that even in an app store model that you actually establish trust in something is you look, who recommends this? How many reviews does it have? How long has it existed? And so so that's like why we want and need a marketplace to exist in order for it to scale to users without them getting scammed. And until we get to that point, our first release is probably going to have like a finite set of snaps that like at least we can we're confident are were implemented rigorously. If they're managing keys, they were perhaps audited, and like we know they're not like outright trying to steal your stuff. But preventing scams in a like permissionless application ecosystem is not a fully solvable problem. But we think by building, by investing in the community and in like a marketplace, we can get there. Next question.
Is not supported in Metamask mobile?
Mobile. Mobile is TBD. It's going. We're working on it. No timelines to announce as of yet. No, they are like the execution environment is the same. The goal is for a snap to be unable to tell if it's executing in the browser, in the server, on a mobile device, on an abacus. Like shouldn't matter. That's the guarantee. Yes.
What's the timeline for snaps?
Yeah, so they are publicly released right now in a developer channel. So like you can download MetaMask Flask and just like get started with the ones that exist. In terms of release to stable, we're targeting early next year. Yes.
How do I get in touch with
That is a great question, kind stranger. And so we have like in the HackMD, there are some links at the top that lead you probably. Yeah, no, yeah, it's locked, whatever. No, it's on the HackMD, which is on the slides, which are accessible through the schedule, like on Devcon. But the MetaMask has a repository called Snaps monorepo. That's snaps-monorepo. And the discussions in there are a great place to get started. We also have a landing page on our website called metamask.io/snaps. That will also get you to a lot of the resources. But the GitHub discussions is a great place to get started. Yes. Mm-hmm. Yes, we are in touch with Google and are working with them to ensure that everybody is happy, and we don't get banned from the Chrome store. How much? All right, I'm being asked to stop, so I'm going to stop. But thank you everyone so much for attending.
Check, check, check.
kind of an interactive session where you're going to be working with the people at your tables. So if you are sitting in the back, just make sure you're able to, you five could chat with each other if you want, but get to a table where you're not alone at least. Joe? It's okay. I just want to make sure that I have this on do not disturb. Think you're good to go? Go ahead. Your mic is on.
Hey everyone, how's it going? So the workshop that we're doing is using the graph in Dune to power on-chain actions. My name's Christian, this is Matthias, and we're from Component. You can find us at component.fi. And we'll quickly go through the agenda so you can get an idea of what we're doing here. So first things first, I just wanted to mention that this will not be a code along. We wanted it to be, but some of the dependencies required, you need pretty good Wi-Fi to download them, so you'd have to run to the basement and come back up. We don't want that, so instead we'll just discuss some of the things that you would have coded. So one, we want to get to know each other. I think that's why a lot of us come here, is to find like-minded individuals. Two, we're going to do an overview of the Web3 data stack. So give you an idea of like the different layers of the Web3 data stack and how you can use them. Three, we're going to do essentially an example that goes through that you would have coded along, but instead we'll just kind of show you how we did it and can give you the information so you can do it yourself later. And that'll be data fetching, so the data fetching process, data processing and modeling, so what you do with that data after you fetch it, and then transaction execution. So essentially a way to grab data, process it, model it, and then have that do an on-chain action, a transaction for you. And then at the end, we'll do breakout sessions just at your tables or whoever you're standing next to. Instead of the coding element, we'll just essentially design your own automation speaking with your table. We'll walk you through it.
We'll do some engineering instead of coding.
Cool. So this is actually my email. I don't know if you're familiar with Questrade. It's a Canadian company for trading stocks and using derivatives. I got margin called a lot, as you can see. It wasn't that much money. It's okay. But I'm not a good trader, basically. And that's kind of my motivation for what we're doing. Because I got margin called so much, I know I'm a bad trader. Maybe automating things and having logic do it for me is probably a better idea. So that's specific to DeFi, but of course, there's many other ways that you can take what we're going to show you and use it, across anything that's built on the blockchain. Okay, so we want to start with everyone just kind of talking to each other at their tables. You can get to know each other, maybe introduce each other. But here's a prompt based on what I just showed you, from myself. And that's a time when things didn't really go your way in Web3. So that could be, you lost money trading derivatives, not in Web3. You can talk about that too. A time when maybe you suffered a lot of impermanent loss, or you can say good things too. I mean, or a time when you should have sold the NFT at the top, that kind of thing. So yeah, take 5 minutes and chat with the folks around you. Hello.
You want me to? I go. I mean, do you want to go? I don't think so. Yeah. Really kind of The thing is, there's also a very large imbalance inside. There's also an imbalance inside. We should have just scattered out the exact. So whoever's talking, you guys can finish up. We're just going to start in 30 seconds. Oh, we have a bunch of subjects. All right, if I can get everybody's attention again. Thank you very much. So we're going to give a little overview of the Web3 data stack. There's a lot here, and we're not going to have everything. So absolutely, if you're a data protocol, please reach out. Maybe we can add it to our slides. So we'll start with this nice little visual from Andrew Hong on Twitter. This was made about 8 months ago. And so here's a breakdown of a lot of the different sort of layers of the Web3 data stack, mostly relating to Ethereum and EVM chains. So obviously you have your sort of base layer where you're actually running clients, interacting with the Ethereum blockchain state directly, reading logs, call data, etc. You have nodes as a service, so you don't have to do that yourself, but you're still operating on those sort of raw data streams. And then you have a layer on top of that. You can think of that as the query and data mapping layer. There's a little more structure there. Often these things are indexed. They're potentially Dune Analytics takes your ABIs and does some contract decoding, so you can actually read the parameters and the function names instead of looking at a bunch of hex codes. There's Flipside and the graph, and everybody knows those. Then there's sort of that layer on top, and this obviously encompasses a lot of things, but they're higher touch, much more customized APIs. The data might be a lot more contextualized and a lot more useful for specific applications, but potentially a little more obtuse. Some APIs, are that data processing is happening in the background, and you don't necessarily know. So those are things like, Covalent, Etherscan, some manual tagging systems like through Nansen. And then we have a few that we use pretty regularly, so we wanted to make sure they made it on there. And a lot has changed in the last 8 months. So people know CryptoStats, David Mihai. They run like crypto fees and L2 fees and all of those different front ends. They've built a little, data processing stack to make it easier to build front ends with subgraph data. The Dune is releasing their API. We mentioned the Dune, but API changes things pretty significantly. We use the Masari standardized DeFi subgraphs pretty much on a daily basis. They've created, an open standard for different kinds of DeFi primitives across chains. If you want a little more control, ETHETL and TrueBlocks are pretty great. They're both open tools allowing you to index from your own node, and even the ETHETL data is available in a BigQuery database. So you don't actually have to do your own indexing if you don't want to. DeFi Llama, they pump out a ton of new APIs and new protocols. Their adapters are a pretty cool system. And then we have another one, Spec. They do allow you to sync your own Postgres database with TypeScript transformers, bringing in call data, bringing in transaction data, indexing it, and then bringing it into your own Postgres database to live beside your own data.
Cool. So this is the process, as I mentioned, that we're going to be going through. So first thing we're going to do is we're going to do data fetching. And for each of these sections, we're going to talk about the alternatives to what we're doing. So to give you like a little bit of flavor, so you're not stuck with one thing. And then we'll run through the example that we actually did. But yeah, just an overview of data fetching, processing, modeling, transaction execution. So our example is using Python to collect data and write a simple prediction model. So yeah, the 3 steps are pulling ETH price data from the graph in Dune, just to have kind of 2 data sets to compare and to show you, 2 different ways that you can do it. And then using a auto-regressive moving average model to predict price movement. I wouldn't use that approach at home, but for this presentation, it works. Basically, if price go up, swap USDC to ETH on Uniswap. That's the transaction that will automatically happen.
Obviously, this was built originally as a code along, so we tried to keep it as simple as possible. A lot of this can be expanded on pretty thoroughly. So obviously we went over that data stack, and there's so much there, so many different choices to be made, and like any other choice you're making when building a product, it's mostly about trade-offs, engineering choices. So we wanted to talk about some considerations to keep in mind. There are definitely others, but some big ones are available fields. Do they actually have the information that you need to use? The data format, are you going to have to wrangle all this data to have it usable in your automations? Scope, does it cover the chains and protocols that you want to use? Are you going to have to, merge different data streams in order to get information from cross-chain, cross-protocol? Is it event-driven or is it pulled? Flexibility, can you extend the model? Stability, are they going to change their interface on you while you're running your automations and break everything? Because for some reason we still don't version control APIs everywhere. Latency, if your application requires is real time, you can't be operating an hour behind blocks. Trust, reliability, and redundancy. Openness of the actual transformation functions. So, understanding how that data was transformed from raw inputs to the data you're looking at now, and then openness of the data itself. If you want to be able to inspect the internal state, can you just get a dump of the database and check it out? Those are all some pretty important things. So we are, in our example, we are just fetching ETH/USD price data from both Graph and Dune. Of course, this could be done through most of the APIs that we mentioned. We like working with both tools, and so this was just a nice little example of using those. Handle Dune first?
Yeah, we'll start with Dune. So very simple query here. We're actually just using a Dune created or a user created table, which gives you prices of different ERC20s on layer 1 Ethereum. And here you can see we're basically just pulling in the time, which we're changing to hour because we want hourly price, and then we're doing the average of the price of ETH over that hour, and then we're doing the max price and the min price during that hour for the last 30 days.
And you'll see this query has a query ID here. That's going to be relevant in a second.
Cool. So yeah, as we said, we don't have access to the Dune API right now. If someone from Dune is here, please let us know. We'd love to use it. So instead, we're using this open source SDK that grabs essentially the data from a query. It's limiting in the sense that you can't actually run the query using this. So you basically, every time you want to do this, you'd have to go back to Dune, run the query, and then come back here and it'll update after you run this function. But yeah, basically it's just grabbing kind of that static data from the query the last time it was run. Then, yeah, if you just scroll up a little bit to data 1, 2, 3. Yeah, just quickly mention this. It's not that significant, but we're basically just changing the JSON format that we get in the response, and we're turning it into a pandas data frame. Are people here familiar with pandas data frame? A lot of nods. Okay, cool. Rows and columns. Cool. And then, yeah, I'll pass it over to you.
Yeah, there's a little bit of processing here to get the data wrangled, so it's consistent across both Dune and the graph. This one is the graph data pull. So we're specifying the endpoint. We're just using a chain link prices subgraph here. In fact, this data isn't actually hourly data. So we first, we're using GraphQL to query the graph. We're just looking for the ETH USD asset pair. We're ordering by timestamp, so we get the newest data. We're ordering descending, and we're grabbing the first 1,000 prices as well as the timestamps associated with that. Then we do the exact same thing here, except we do one thing, which is resampling, so that we only end up with one timestamp every hour, or one price every hour instead of multiple. And here's just an example of the outputs. You'll notice that there's actually inconsistency between price and price here. That's because the Dune table actually does this in decimal format, while the graph here, this subgraph specifically, looks like 8 decimal points. The fact is we're running this model separately, so it doesn't really matter for this example, but it's just one of those things to pay attention to. Obviously, your data needs to be consistent.
Yeah, and one thing I'll mention about that as well is it's actually great to use more than one data source, just so you can actually check these things. It's hard to know what the source of truth is. So, using different data sources, checking them against each other, maybe before you run something is always a good idea. And another thing is, we didn't really mention this, but with the data we're pulling, this is a simple example, but the really cool thing is that anything on chain is fair game in terms of data that you can use. So think LPing, lending protocols, on-chain derivatives protocols, NFTs. It doesn't have to be DeFi related. You can do some pretty sophisticated stuff with different types of data. So yeah, moving into this section now. So data processing and modeling. Now we're at the point where we have the Dune query and the graph query pulled in using Python, and now we want to model it essentially. So before we jump back into the code, there's just a few considerations. Kind of like just what I said with there's so much composability when it comes to data. There's also infinite composability when it comes to modeling. You could use, instead of using a time series prediction, you could do conditional logic, like maybe there's someone you follow that trades really well, and anytime that they make a trade, you want to mimic it right away, stuff like that. Or if someone like me is not a good trader, you can take the opposite position. Then of course there's so many types of machine learning algorithms, time series predictions. The list goes on and on for the types you can do.
And again, I know we're focused on DeFi for this presentation, because that's mostly what we interact with. But if you're really into stable diffusion and you want to see text generated images, you could always grab text from your Lens protocol interactions and generate an image based on it and mint an NFT on chain if you wanted to, something like that. That's really up to you. Because all this computation is done off chain, the sky is the limit.
Cool. So quickly, just on the, I guess the modeling, we already did the processing, I guess, earlier when we just reformatted stuff into a pandas data frame. So here it's quite simple. If you're familiar with like a little bit of data science, I'm not a data scientist myself, but what we do is we basically split the data that we pulled in, so the Dune data and the graph data, and we split it into a train and test set. Just basically 80% train, 20% test. Not that sophisticated. And then what we plot it, and we'll show we'll show the results after, and then we run it through a ARMA model, so autoaggressive moving average model, to essentially predict. So we're doing this by hour, and the goal here is to predict whether the price of ETH in USD is going to go up in the next hour. And so the logic here is basically just if the next hour price is greater than the last price, then we want to buy ETH. If it's less, then we want to sell or short or what have you.
It's that easy, folks.
Not financial advice. Cool. Yeah, these are the results. So as you can see, the red here is the test set. And we are basically, the prediction is basically saying it's trading sideways. Maybe I think it probably goes down about $10 roughly. If anyone knows the crab strategy on Squeeth, this would be a good time to use it, I guess. Yeah, these are just the results.
Yeah, so the most Web3 relevant, probably the most complicated step in automation here is transaction execution. So there's a number of ways to do it. So bringing these insights back on chain. So there's tons of considerations to think about. Which chains you're operating on, is the environment adversarial? So are you, if you're working in DeFi, then you're probably looking out for MEV and sandwich attacks, anybody trying to exploit your model. If you're, minting NFTs for art purposes and not for financial purposes, it's probably less of a big deal that someone front runs you. What kind of timeline are you operating on? Some things have much larger delays than others. Key management, do you want to manage your own keys? What kind of permissions do those keys have? Should your logic be transparent? So, if you're running a proprietary trading algorithm, you probably want that to be executed off chain and just have the results posted to the chain. But if you're running something that you want to be transparent, you would likely want the computation to be visible on chain. What happens if a transaction fails, if it's congested? These are things that are annoying for manual transactions, but if you're not taking them into account when you're automating transactions, you can get something stuck in the mempool forever. You can potentially end up not being able to transact if you're not, replacing that transaction and replacing that nonce. So there's a bunch of options. There are almost certainly others as well. And these are not necessarily mutually exclusive. They're just kind of ideas of part of it. So, libraries that wrap on top of, the wallet APIs that translate JSON RPC, Ether's Web3.js, Web3.py, which we're using in this example. If you're running something like that, it's probably in some sort of function that you can either be running, locally or on a cloud. You can, use traditional cloud service providers, or, Tenderly has their new Web3 actions, which is effectively lambdas for Web3 interactions that can be triggered by events. Keeper networks. So some keeper networks support like more complex off-chain logic. Some only support triggering, transactions with a function signature. There are transaction execution services. So something like OpenZeppelin Defender Relay and Infura transaction services, they handle a lot of these questions that are kind of annoying for a small development team to deal with. So things like key management, they allow you to hook into a KMS system. They also handle, figuring out gas fees. So if a transaction fails in the first, or a transaction is waiting too long in the mempool because it doesn't have a high enough gas price assigned, then it will actually ramp those up progressively, and it tries to figure out, how much gas do we need to be able to execute this transaction in a certain amount of time, that being the variable you set. You need to make the decision, if you're not actually doing execution and you're just posting data to the chain, then you might want to execute more like an Oracle model. So just posting data. You're not necessarily thinking about execution then, you're more thinking about on-chain execution, that is, you're more thinking about how do I get a reliable reliable posting of results to the chain. You can go through a multi-sig if you don't trust your automation. You could have them as one of the signers of a one of two multi-sig, where they basically are queuing up that transaction, send yourself a notification, and then accept or reject. That might be the most thing that most people are more comfortable with. You could potentially run the actual, run some of this logic on an L2. So what's the name of the Starknet? Not Starknet itself.
The Oracle,
the machine learning model on Starknet.
Yeah. There's a company called Modulus Labs. They're doing some pretty cool stuff. So they created this thing called RockyBot. That basically does what Matthias was saying, where they're running, it's on Starknet, and they're leveraging that and just basically posting the result to the chain. So it's like a neural network on chain. It's very cool. Definitely check it out.
Yeah, and then I'm not very familiar with MEV or being a searcher, so I'm sure there's other people who can expand on this. But in that case, you're probably using something more dedicated. You're building bundles using the Builder API, I believe. And for this example, we're just using web3.py. This is probably the thing that people are actually the most familiar with. We're just setting some variables. We're selecting our chain being girly. We're grabbing an RPC provider. There's some middleware that's required for girly here. We're grabbing a private key from environment variables, which of course means we have to manage that ourselves. And then we are executing transaction. In this case, we are swapping on Uniswap v2's router. So we're grabbing the ABI, using that to encode our function signature, and setting some parameters and posting that to the chain.
Cool. So before we go into this, just wanted to recap. So we used Subgraph to pull ETH USD price data. We used Dune to pull ETH USD price data, and we processed it. We using Python pandas, and then we used Web3.py to actually send the transaction.
That's actually what we were supposed to show. Just putting it all together. It's again, 3 steps here really. I'll grab graph and Dune, formatted data. Check with the model whether we should buy based on the graph model, whether we should buy based on the Dune model, and if both are true, we are buying.
Yeah, and one more thing to say here is, so this makes it look easy, and that's actually what we're working on at Component. So we're working on something called Blueprint that abstracts away all the stuff we just had to do. Although it's really fun to learn how it's done, and you can definitely do it that way, and to see how it's done under the hood. But what we do with that product is essentially try and take you to this step without having to do all the other stuff.
Okay, I guess it's me. So you guys saw what we came up with. Now it's your turn. This might be a little long with the 10 minutes, but I'm sure everyone who came here has something in Web3 that they're passionate about. That thing probably is generating quite a bit of data, and that's probably available through one of the many services we mentioned. So we'd like you to take a little bit of time, explore some data sets, think about what kind of automation you could build using those as your input. You can work as individuals or as a group to start. After that, we're going to sort of have little 30-second pitches to everybody else on your table, and you'll decide on one to sort of design as a group.
Yeah, so just to give you an idea of what you could do. So anything in DeFi where you're triggering based on a prediction model or based on some conditional logic, could be to sweep the floor of an NFT collection. The really anything you want and any data that comes to mind that's particular to you and what you're doing.
And remind you to kind of be thinking about those 3 steps: where I'm getting the data from, how I'm going to process it, and then how I'm going to actually generate something actionable from it.
Yeah, go ahead.
Now we should go around, right? Supposed to.
Yes, that's okay. I appreciate it. I can't. This question is about what is the purpose of the data set? We need to the data set, sorry, purpose of the automation of a data set. How an example I use another example. Yeah, crypto trading bot. No, that's okay. Yeah, the app. No, that's it. Good noble money. You should track that as problem. That's very good. Yeah, of course. So go ahead. Did I answer your question? No? No, I didn't. No problem.
We just tell them to start pitching, to start deciding on an idea at least. I don't want to break the flow of ideas too much, but if you haven't kind of centralized around one idea yet, now would be time to potentially pitch and try to get your idea chosen.
I think we'll get everybody to say their idea out loud so that there's a little bit of, yeah.
All right, folks. We're happy if a few people came up with an idea and like thought about the process. And I think if you did, anyone come up with an idea? Raise your hand if you did. You want to talk about it?
So we think that kind of DeFi investing has been quite risky forever. And so the idea is kind of a generalized pressure release valve. So if a condition is met, whatever investment you have, if it crosses over that threshold, then pull out, pull out to wallet essentially. So you could think of a liquidity pool, you're invested in there, but if the two assets start deviating beyond a certain range, then you exit that position.
Thank you, Greg. Anyone else? You look like you have an idea. You do, okay. Quick pitch here. Let's hear it.
I'll try to make it very quick. Yeah, what I've learned throughout a lot of very horrible loss experiences is that you have to optimize your buys. That's a strategy for centralized finance. I mean, centralized trading, but it does work for DeFi and LPing, and it's basically spotting when the price hits a threshold, and when it's oversold within the Bollinger Bands, like in the lower part of the Bollinger Bands, and you want to do that. You want to identify that buy signal throughout different temporalities. Sorry. Like the weekly time frame, the daily time frame, and maybe no shorter term time frames, maybe the 3-day time frame. I don't know, but identifying buy signals throughout different temporalities using the Bollinger Bands. That's basically it.
Oh, is it working? Yeah. You look like you have an idea. No? Okay. You have an idea? Okay.
So we discussed an idea of auto-rebalancing crypto index. So let's say you want to build a simple index that's like 50% wrapped BTC, 50% wrapped ETH. Over time, that balance is going to be different than 50-50 if the price of Bitcoin increases, for example. So maybe using some kind of feed like that to calculate the balance of your portfolio and rebalance every hour, week, whatever.
Cool. Yeah, rebalancing I think is a very good use case, like in whether it's just a simple spot trading portfolio, or it's something a little more complicated like LPing or lending or borrowing, that kind of stuff. Do we have time for one more, maybe?
Yeah, we have a little time.
Okay.
It's okay.
Anyone else? Cool.
So, we were none of us were actually in DeFi space, but we actually thought about some other use cases. I'm working on a reputation computation protocol based upon pairwise trust, like who trusts whom by how much, and then like my output would be basically the number crunching would be like after all that like recursive calculation, like each peer in my network is assigned a trust score, right? And like he's actually from the DAO space, and we talked about how we can actually use this this type of algorithm in like voting versus like civil prevention. Typically, my algorithm is pretty good at like identifying the civil clusters who actually trust each other, but like none of the other real people actually trust any of them. So maybe we can actually ingest this data and then do that number crunching, identify those civil cluster, and then his DAO could actually emit something onto the contract so as to flag those accounts as potential civil, maybe like avoid them, things like that.
Cool. Thank you. Maybe one more if anyone has one. If not, it's okay. Anyone keen to share? Adrian, you look like you want to share. You're writing your idea, right, on your phone? Okay, later. Okay, cool. Yeah, that's it. So we'll just wrap things up here. Yeah, we don't have time for that, I don't think. So we'll just go to the last slide, I guess.
Yeah, if you want to run with any of these, just remember to think about, like, we have the basic idea right now, but there's a lot more to it. Think adversarially. Where are the attack vectors? How could your strategy be manipulated? Be defensive.
Yeah, and then just to close things out, to mention what we're doing again. So at Component, we're building something called Blueprint, and all of your ideas, except for maybe the last one, that sounded really cool, but it was a little over my head, but very, very cool. But for the DeFi related stuff, at least, and would love to talk to you about what you're doing to see if we can incorporate that in the stack. So if you have any ideas that you actually want to execute on, or you have friends that like want to build these kind of data-driven strategies, we're building tools that basically make the entire process easy. So you only have to worry about the logic of what you're building. So yeah, that wraps it up. Thank you, everyone.
Thanks a lot. I know it was an unconventional workshop, but I appreciate that everybody was talkative and engaging instead of just hanging out on their phones and things like that. So it's great.
comments.
Okay. Check. Check, check.
Thank you so much. No, just yes. To change the date.
Very good. Thanks.
Thank you. Nice. You got nice.
Hey there. Thanks for coming, everyone. I'm Zero Age. This is Ryan. We're with OpenSea, and we're going to talk about the Seaport marketplace and some more advanced techniques for how to utilize it and interact with it and build on top. So, Seaport is a beast. It's a single contract, but there's a lot going on, and so we're going to work our way through. First, start with some of the high-level key points, and then from there we'll get into some of these advanced techniques. So, first thing to understand is that there are two arrays that dictate the basics of a Seaport listing or offer. The first is the offer, and that's all of the items, native tokens, ERC20, ERC721, 1155, that you, the offerer, are going to spend. Then, on the other end, you have the consideration, which is everything that you or others are going to get back. If you want to spend the offer items, you got to get the consideration. So there's also this idea of a zone. Every Seaport order has an optional zone that you can set. That's a contract that gives a thumbs up or a thumbs down on whether that particular order is still valid. There's also a concept of a conduit, which is it's a contract that you can approve to transfer your tokens. So you set your approvals on the conduit, and from there, you can set additional marketplaces or contracts on that conduit, support multiple marketplaces, migrate to new versions of Seaport, so on and so forth. So when it comes time to create an order, to list your NFT, the primary way to do it is you just sign an off-chain listing. This is an example payload that you would see in Metamask. You're going to have to pop open the expanded view to get this whole thing, but it's got the offer array, consideration array, start time, end time, zone, conduit. Then another method you can use to create an order is to call this function validate. And that means you don't need a signature at all. You just provide the order and it gets listed on chain, so to speak. The interesting thing about both signing an order or calling validate is you have to explicitly cancel. You have to actually call and tell Seaport, I'm no longer interested in filling this. Signatures are not just standard ECDSA, they're also support for 1271, which is valid signature. Seaport will give the offerer a digest, basically the order hash, and a signature, and then leave it up to the contract to say, yes, this order is good, this one's not. And that works with both traditional signatures as well as validations. And you can use this technique to list from a smart wallet or a multi-sig without having to pay gas. But you can also, and here we start to get into the advanced techniques, you can utilize 1271 to do dynamic orders where you might have a contract that's willing to, it wants to update the order based on a price that's coming back from an oracle, or maybe it's implementing a bonding curve, or it's a pool, something to that effect. So what you do is instead of giving the signature for 1271, you actually give the order itself. Then, and there's a trick you can do here where you can actually supply an offset to call data that reuses the same segment of call data that you already provided with the order and cut down on the overhead of doing this. But then what the offerer that's getting called will basically have to do is rehash the order, derive that digest, and compare it to the one that was supplied by 1271. Then it knows that the order that you gave as the signature is in fact the correct order that's being filled at the moment. And then it can go and look, okay, let's check out this offer item, this consideration item, and make sure that they match whatever the latest state that we expect is. So that's a really interesting technique to do more dynamic orders. You got a question? So this is not zones. This is if you have a contract that is going to serve as an offerer. And so it could have its own validation logic on the contract as part of this. But it could also utilize a zone, right? That's very much something that it could piggyback on validation logic in a zone. All right, so that's creating orders. Let's talk about fulfilling them. The standard method for fulfilling an order is to call this function fulfill order. Or fulfill orders is the actual function. And you basically just give this whole payload, just like the payload that you signed, you provide it to this function, and it creates an implied second order, a mirror image of the first one, where every item that's being offered on the order you're fulfilling, you just say, all right, I will take that, and take all of those items. Those are your consideration items with you as the recipient. Then look at all those consideration items. I'll send those out. I'll pay them. That's the basic method. But there's also a basic method, which is there's a small subset of orders that actually constitute a pretty wide swath of what people are generally doing, which is, I want to buy an NFT. I want to sell an NFT. And maybe pay a fee. Seaport doesn't actually have a notion of fees at all. So everything is just another item. But if you have one of these simple subsets, you got a single offer item, you've got one or more consideration items, and you take that sum total of all the items, there's one NFT. That's part of that. Everything else is a single item type. They're all WETH, or they're all DAI, or something like that. Then you can call this other function and it performs a more optimized fulfillment. Less call data, you just need to supply a subset, like give all the additional recipients, which spells out, usually it's used for fees. And on top of that, the basic fulfillment methods have a slight deviation where if the offer is, the item is a ERC20 token or native token, then it will be used to pay for all the non-NFT consideration items. So you don't have to take everything. You can minimize the number of transfers that are occurring. That's a common theme with, you'll see, as we get into these subsequent fulfillment methods, it's all about cutting down on the top efficiency gain is from reducing the number of transfers, right? Particularly with tokens. Native tokens a little different, but with other tokens, it gets very expensive if you're doing redundant transfers. So when you want to buy 5 NFTs, you want to sweep the floor, right? Oftentimes, you'll have each one of those has a fee attached. What if that fee recipient is the same recipient? You don't want to do 5 transfers, you want to do 1. So we use this fulfill available orders method. This basically goes through each order and says, has this been fulfilled? Has it been canceled? If it's still valid, then we'll go for it. If the order is not valid anymore, we'll skip it. And you supply you basically point to, okay, this order, this item, that order, that item. These all have the exact same item type. They all have the same ID. If you're talking about an 1155 token, they all have the same recipient. Effectively, they can be condensed into a single transfer. Cuts down a lot on the number of transfers there. Then you have this method, match orders. When you're talking about fulfill orders, fulfill available orders, Seaport's not going to be able to figure out on its own how to do these transfers. The way that it works is you're going to walk through every single fulfillment, and it's the same idea as fulfill available orders. Here's the order, here's an item. Here's another item, here's another item. Let's aggregate all these together. Then we're going to match those with this item, this item, this item on these orders on the consideration side. And that whole group gets distilled down into a single transfer. So this method it's not utilized as often if you just want to buy an NFT. This is what you really want to reach for in the power use cases, where you have maybe you're searching, like you're looking for MEV, where you can find a price mismatch, or you want to compose multiple different orders with zones and get them to all fit together in a neat little puzzle piece. The big thing to be aware of with this is that if there's a problem, after you supply all these fulfillments, it's going to go through and make sure that every single consideration item on every single order has been fully credited. It's got to be 0 on every single one, or else the whole batch will come crashing down. It'll revert. So definitely, this is the power feature, and the first thing you want to reach for if you're looking for searching or more advanced strategies. Okay, let's talk about some zones. Zones is it's the main mechanic by which you would extend Seaport. Any order can choose its own zone and then say, I'm a restricted order. Set the type as restricted. Now the zone gets to decide whether or not the order is good or bad. And in addition, you can always extend the consideration array. You can always add items as the fulfiller. We call them tips. It's cool because you can take an order that came from one marketplace, you can fulfill it on another and apply a tip. What you can also do is you can use logic in the zones to ensure that the tip that got supplied matches whatever it is that you expect it to. Maybe that's a dynamic calculation of on-chain royalties, right? Something like that. So let's talk about a couple potential zones, things you could use them for. So one application of zones is for dynamic NFT metadata. Certain items in Seaport, they're called criteria-based items. And in place of giving a token ID, an identifier, you instead give a Merkle root. And this Merkle root is comprised of all the token IDs that are valid. Or you can give an empty one, and that signifies it's a wildcard. You can pick whatever token ID you want. But this only gives you so much granularity because at the time that you sign the order, it might have certain metadata. But maybe the metadata gets updated, right? So the traits, the attributes that this had at the time you created the order, they've changed now. So you can obviously leverage zones for this. Anytime that a creator of an NFT updates their metadata, they go and they update the zone, registering that, hey, this particular Merkle root is actually now this other one, right? And you can't match the tokens that have changed. Another potential use case is for compromised NFTs. You might have an NFT that gets stolen and you don't want to be able to trade it anymore. And that's one potential use case for a zone, is to just check and make sure that the items that are part of the order are no longer fulfillable. Another cool potential use case is for front-running resistance. Say I have a zone where I have to call 5 minutes ahead of time and commit, similar to how you would do it with, I believe ENS has a similar thing. You register ahead of time and say, I want to fill this. Then you wait some period of time, and then you reveal. You include as part of the parameters called extra data. When you're fulfilling, that gets passed along to the zone. The zone then can look and say, oh, I'm going to hash this. It looks like you committed to being able to fulfill this order. Another interesting one is leveraging oracles. Maybe I have a listing. I don't want this listing to be fulfillable if the floor falls out. So I could read from an oracle that is periodically updated, and if the price drifts too much, then cancel the order. Don't let it be fulfilled. Or you can even leverage this along with that trick with dynamic orders with 1271 to create a strategy that will buy NFTs below the floor price, sell NFTs above the floor price, that kind of thing. So here's some links. We've got obviously the Seaport repo itself, as well as any questions, or you want to get into the weeds. The discussions there are a great place for that. Seaport.js is a library for interacting with Seaport. Makes a lot of this stuff much more straightforward. One thing that I will note is that much of the match orders functionality is a little more rough around the edges. Would love any contributions if anyone finds themselves working on that. And then this last link, Seaport Order Validator. This is a contract that we put together to make it easier for checking an order, or if you are accepting new orders coming in. There's a lot of gotchas, things that can go wrong. And it's a quick way to say, oh, this order looks like you're not actually getting anything from the order, right? You're not set as one of the recipients on a consideration item. You sure you want to do this? There's 100 permutations of things that can be maybe a warning or an outright error, right? So it'll check on-chain registry for creator information, like make sure that the tokens implement EIP 165, that you're not trying to pretend like one token that's actually a NFT is an ERC20 token, something like that. All kinds of interesting stuff. And if you're trying to just piece together the potential things that can go wrong, this is a great resource. So, how are we doing on time? All right, I think we can open it up for discussion. First off, if anybody is currently building on top of Seaport and has a sticking point or a question, by all means, let's hear them. Yeah, here, let me bring the mic over.
I am not building on Seaport at the moment, but I do have a question.
Great, yes.
So certain NFTs have royalties associated with them. And I was wondering, do you include the royalties in the orders themselves, or does that get handled somewhere else in the contract? And if so, how does optimization happen on that front?
Yeah, so the basic approach, as I mentioned earlier, Seaport doesn't have any notion of fees or royalties that's baked in. It's just, you could very easily create an order that doesn't include any fees or royalties whatsoever. So it's really up to the discretion of the application layer, whoever's building on top of it. One approach you can take that I think is a pretty good one is to just read from the registries at the time the order is created. This, depending on your perspective, is either a feature or a bug. One thing that I would consider a bug is if when I go to create a listing, the royalty is 5%. And I'm like, okay, I signed my listing. Now the creator goes and changes that to 50%. That's a problem, and I might not have listed it if I knew that I was going to have to pay that, right? Then there's also the question of, well, what if they just want to tweak the recipient of the royalty or something like that? For those cases, you can leverage tipping, right? So I mentioned earlier that you can always add additional items to the consideration array. You can't add them to the offer array. You can't decide that the offerer is going to spend more than they originally agreed to. That's a very important invariant not to break. But you can always say, oh yeah, I'll give out something extra. You combine that with, call it a royalty zone. The royalty zone will go, it will read in real time from the registry and ensure that the last consideration item, this tip, matches what the registry has on file. So then the only way you're going to be able to fulfill it is to supply the correct updated information. That's sort of the gist.
Cool, thank you.
Cool. Yes.
I have a question about one of your earlier slides. So you, on the matching orders slide, you have this statement which you wrote something along the lines of like, if a searcher identifies an opportunity, there it is. So a searcher identifies an opportunity, can take whatever leftover item amounts and match them to a new consideration item to itself. So I'm a little confused because my understanding of the architecture is that in every single type of order or function call you make, all considerations have to be met on the other side. So I'm a little confused how like in the case of like the classic case of arbitrage, right? Like there has to be an opportunity on the table for the arbitrager to take, and it's not clear to me what this means for an opportunity if the considerations are always evened out, or
yeah,
what that means.
It's a great question, and this is actually a good opportunity to get into just the nitty gritty on how this would look. Let's just consider a really simple stripped down case where you have one listing. So the way this might look is I want to sell my NFT, right? So I have one offer item, which is my NFT, and one consideration item, we'll call it 5 WETH, okay? With the recipient being me, the offerer, right? Now someone else likes my NFT. They don't realize that I've already listed it for 5 WETH, okay? They put out an offer a bid on the NFT to buy it. And they offer 6 WETH. So the way it would look for them is I'm offering 6 WETH, 1 offer item, 1 consideration item. This NFT recipient is me. So now person number 3, searcher, comes along and realizes that there's this mismatch. They call match orders. They supply both of these orders, and they give a fulfillment saying, okay, order 0, item 0 is the NFT. Order 1, item 0 on the consideration side is also the NFT. These match. That turns into a single transfer from the offerer A to offerer B. Then we do another match fulfillment, order 0, item, I'm sorry, order 1, item 0, which is the 6 WETH. Order 0, item 0 on the consideration side is the 5 WETH. Those now match. The way that this works now is that they get the 5 WETH gets credited. Okay, that's been accounted for. The 6 WETH gets spent. There's 1 WETH left. You can actually leave offer item amounts on the table. There's not a reason that you have to spend all of the offer items, but you do have to credit all of the consideration items. So we could leave it at that. You could match those 2 orders, and the original, or the order B, the person that made the bid, just end up paying 5. But what would, in practice, what would happen is that the person who located the opportunity might say, I'm going to create a 3rd order. And this 3rd order, I'm offering nothing. It's an empty array. Consideration item, 1 WETH, recipient is me. And then they create another fulfillment that, matches the same one that we've just spent 5 from with the new one. You don't even have to create a new order. You can also just add on a tip to order B or whatever and use that to match 2. So that's the idea there. Other questions?
Okay, thanks. So haven't built anything on Seaport, but I've looked into it a little bit. Just wondering, does it support like natively partial fill orders? Like, is it possible to do
yes,
single sign message with like multiple fulfillments?
Yeah, I'll get into that a little bit. So if the offerer elects to support partial fills, it's specified in the order type, just like a restricted order when the zone requires that. So if an order supports partial fills, the way that this works is that you can supply, when you call a normal, it's like fulfill order, fulfill available orders, match orders. Those don't do partial fills, but there's also fulfill advanced orders, match advanced orders, fulfill available advanced orders. Those you give criteria resolvers, basically Merkle proofs for the criteria-based items, as well as a fill fraction, a numerator and a denominator. And the heuristic is that every single, assuming that the order supports it, every single offer item and every single consideration item is going to get that fraction applied to it. And then once the order is fulfilled, it's just going to update with the fraction, say, here's how much has been fulfilled. The rule, to avoid any kind of weirdness around rounding errors, is that every single one of those fractions has got to be exact. There can be no remainder after applying the fraction. So in general, when you're constructing an order that supports partial fills from the get-go, the easiest way to do it is to start with a single quantity, right? I have some ERC 1155 tokens that I want to sell for 1 ETH each, right? I want to sell 10, so I'll now just take the 1 ETH, multiply that by 10. Take all the fees that were already calculated, multiply those by 10. So it'll be a nice, even fraction that's applied. The math behind that on the contract is also pretty cool. Uses the Euclidean algorithm to ensure that there's, if there's an overflow, it can all be rounded down to the greatest common divisor. But that's a different topic. Yes, there's partial fills, and once the fraction, the fill fraction is applied, and all the criteria resolvers are applied, then it's all the exact same flow as with the standard stuff. Yeah.
Hey there. Can you talk a little bit about extra cheap signatures and when they should be used?
About what signatures?
Extra cheap. I see that's a parameter when you're creating an order. And I think you use EIP 2098 in that case.
Oh, yeah. So 2098 is the 64-byte signatures. So a standard ECDSA in Ethereum has 3 parameters, right? V, R, and S. And turns out that there's a parity to the V, right? It's almost always 27 or 28, right? And there's basically a signature malleability concern there where you have 2 exactly identical, or the signatures are different, but they resolve to the same, they recover to the same signer. The trick is basically to say, what if we just always flip the parity, right? So you can take any 65-byte signature and you compress, you flip it so that the parity is always, I think, 27. Mm-hmm. And then you also can, because when the parity is that 27, then the S value won't use the most significant bit. So then you can compress V and S into a single word. You basically take what was once 3, now it's just 2 words. So you cut down on a word of call data in standard ABI encoding, which you're looking at what 130 bytes or 130 gas for those bytes, and just a minor optimization that you can employ. That's the idea.
Nice, thank you.
Great questions, everybody.
Hey.
Hi.
So assume I'm trying to do like a searching strategy, right? So to help users with gas, you may take like signed orders, right? And those are not visible on chain. So for a searcher to like look through all the possibilities of orders out there that I could possibly fill with a match order, where would I get a list of all the orders that are not on chain? Like, is there a HTTP API that I could call?
So this really it delves into less of how does Seaport do it, and more, all right, what about the marketplaces? They're built on top of Seaport, right? We work at OpenSea. We have an API. If you have access to the API, then you can read from the API and get a sense of the orders. There are also other marketplaces that are built on top of Seaport. You might want to be pulling from those. Right. But it does get more complicated to find all of that. You can listen on chain for the validate events,
right,
which is one way to do it. You can listen in the mempool is another way.
Right.
So, but there is, I think it's definitely an area of active investigation to figure out how to best democratize that search.
Okay, thank you.
Yeah, I guess 2 questions on my end. One is does Seaport support swaps of NFTs today?
Absolutely. So when you look at an offer consideration, the items, ETH or native tokens, ERC20, 721, 1155, any combo of those, Seaport is totally fine with. The exception is the fulfill basic order method does have more opinionated subset of possible orders that it's going to support. But yeah, Seaport was built with this idea of barter, like NFT for NFT as a first class citizen.
Yeah, I guess the second question I have might be a little bit, of a comparison question. So we are right now integrated with like 0xv3 for
Awesome.
sort of a private marketplace. So I'm just curious. I mean, maybe you can speak to like some of the differences between Seaport and 0xv3. If there's any? Yeah.
Yeah. So first off, 0x is really cool. They are definite innovators in the space. 0x is more geared around single NFT, like buy an NFT, sell an NFT. And it's actually a very good protocol for that. Seaport is more geared around how do you grow out from that. There's less opinionated on this, what the exact structure of a listing looks like. Basically, for the exact reasons that we just were discussing, is a top one. Another thing that is different is that Seaport is totally unowned and permissionless. There's no special notion of like a protocol token or a protocol fee that could be turned on. It's just meant to serve as a permissionless piece of public infrastructure on chain. So that is a difference. But yeah, big fans of what the 0x team has been able to do.
Thanks.
Over here.
I was wondering if, like, currently on OpenSea using Seaport, do they utilize any like interesting zones currently, or do you have to like define that yourself as like someone who like creates a listing on OpenSea?
So I can't speak too directly for OpenSea. I'm one of many, but what I can say is that for at least a couple of months after Seaport first went live, it was a brand new protocol, used a lot of assembly, and so we kept guardrails on. We used a global pausable zone and required that all orders that were sent to OpenSea had this zone set on them. And it would allow for us to basically hit the panic button and just cancel every single order if there was a problem with the marketplace. It's now been long enough, and there are enough interesting use cases for zones that efforts are underway to really open that up. Other chains off of mainnet don't currently use a zone. So stay tuned. Stay tuned on that. And I will also say that if anyone is authoring zones or working on them, get in touch. Let us know. We'll definitely, it would go a long way to help see what zones people are coming up with, and that will definitely inform the discussion and efforts.
We're integrating with Seaport, and
Awesome.
we're having issues with signature verification where recovered signatures match the original signer, but orders fail.
Interesting. Okay.
And it's been unsolvable for me. So what are reasons this could be?
Okay. So if you have an order that's signed and the signature is valid, right? Like you can recover the signature and it works. There are a number of potential things that you could look into. The first would be checking the order validator, right? That's going to scan through and give you a number of potential problems when you go to try and fulfill it. And that's actually, it's a very important thing if you are maintaining listings and offers. You have to ensure that you're not putting listings out that aren't fulfillable, right? So that's one thing to try. Another, Seaport has this notion of a counter. So every single offerer has a counter that's tracked independent of all of their orders. And at any point, you can just call increment counter, and that serves as an eject button where all the orders that are signed with that counter are now invalid. Interestingly, though, you don't supply the counter as an explicit argument. It's an implied argument. So if you have two identical orders, except one has counter 0, one has counter 1, they'll have different order hashes, but the call is the same. So that's one potential area that you can run into issues. The last thing I will say is that cases where there's something really sticky that's just like confusing and not making sense, I would really encourage you to go to this discussions board, both for, it's a great forum to lay out all the information, and also for others to then benefit from figuring it out. And so I'd encourage you to do that. But yeah, signatures are notoriously finicky to work with, and every developer that's had to work with them, there's always a sense of relief when you finally get your workflow figured out and the signatures are working, because it can be quite opaque why things are going wrong.
The counters, though, they only get incremented when you cancel an order.
So it's actually not related to canceling. When I call cancel on an order, that cancels a specific order. And that's actually one of the only times you do explicitly provide the counter. So it's saying, here's a particular order that I want to cancel. When you call increment counter, you don't provide any arguments. You just call increment counter, and it cancels all of your orders that were signed with that counter. Yeah. Two distinct things. Thank you. Other questions? Okay. How are we doing on time? All right. Well, I guess we got another 10 minutes. Maybe we could all workshop. Oh, you have another question? Yeah.
I think this might be a little bit unrelated to Seaport, but more on the API. So any plans on your end to, I guess, make the API more enterprise grade, maybe like a higher TPS and so on?
We're just focused on Seaport, but definitely we can put you in touch with the API team. Maybe we could workshop an interesting zone, something that that would add some new capability to Seaport. Anyone got any ideas? Something you'd like to see? Yeah.
I'm coming a bit late, so I suspect this has already been raised. But is it how about a zone where it's only possible to make sales to certain people? Or I suppose certain addresses, or maybe certain ENS addresses.
That's very possible. Yeah. And that actually reminds me of an interesting advanced technique that is used for private sales. So if say I want to sell just a specific NFT and you are the only person that can buy it. What does that look like, right? How would I set that up? One kind of interesting way of doing that is just to say, all right, single offer item, my NFT. Consideration item 1 is ETH to me. Consideration item 2 is my NFT to you, right? So I've basically just set it all up. But now, if I wanted to go and call these implied mirror order and just fulfill orders on that, it's not going to work, because the offer item from me needs to actually match to the same order, right? The consideration item on that same order. So you got to use match orders for that. And you would then match it with an order from you that just says, I'm just offering the ETH, and there's no consideration item, right? So I'm if I were to just take that order and sign it, then it's effectively a donation, right? But if I fulfill it alongside this other order, now the two of them together make a complete picture. So that's for just a single private sale. But for, say I only want to sell my NFT if you're on this allow list, that's easy enough. You have a zone where you just supply, okay, here is a Merkle proof that says that the fulfiller, the caller, is in the root, right? They're one of a set of people. Or I could check and see like the caller has a balance of this particular token. If I want it to be a token gated thing where only someone that owns this token can buy it from me or something like that. Well, that's all actually, it's pretty straightforward to do with a zone. Hey.
So with like developing new zones and building just generally on top of Seaport, like a new marketplace, do you see it as like what are the steps for doing that? Is that like create a UI that signs messages and then create like your own database and API to serve those messages? Do you see that happening as like the pattern as this scales out, or like develop the zone and then like work with OpenSea to have that zone integrated, or maybe like a mix of both?
Well, we knew that the place to start was with the smart contract, right? The marketplace, it's the hardest and riskiest thing and most expensive to get audited and vetted and all of that. So started with that, the contract. And now that that's in place, really where we go from here is anyone's guess. But I think that if it really depends on the application. If you have a particular flavor of listing that you want to see supported in other marketplaces, then I think the most expedient route to do that would be to go ahead and put it together and then shop it around. And sort of like I mentioned earlier, you know, we would love to see what people are working on, zones they're creating, and that would really help expedite the process and help standardize around certain zones that do specific things really well. For creating a brand new marketplace from the ground up, I think that's it. There still is very much a traditional Web 2 component to it that would need to be undertaken at this stage, but I imagine that too will become more accessible to all soon, is my hope. Yeah.
So you spoke a little bit about private private sales just now. I imagine that OpenSea is not spawning new contracts for zones every time someone does a private sale. Can you walk us through the flow of a private sale in OpenSea today?
Yeah, so there's no zone required on private sales. That's basically just taking the standard order, and normally you'll see an order with it's like the basic order. You'll have a single offer item that's either the tokens that you want to spend or the NFT that you want to sell, and then you'll have one consideration item, the first one by convention. Like if you use the order validation helper thing, the first consideration item is almost always going to be something coming back to you, the offerer, right? And then it'll be followed up by usually fees. Like here's a fee to the marketplace, here's a fee to the creator. That's a standard order that you would see. But in private sales, one way you can do a private sale is you deviate from that standard a little bit, and you just say, I'm actually going to include the recipient, the person that I want to sell this item to, as a consideration item on my order, if that makes sense. So it's like literally, you need to get this, or else you can't take it from me. Yeah, that's the idea.
I guess like for like a zone idea is that like I think when I was reading the like OpenSea's like Wyvern contracts, like there was support for just Dutch auctions and fixed sale or fixed price sales, and they had like a comment in it saying like they wanted to maybe do something more advanced or like English auctions or something like that, right? And I remember watching one of your like I guess it was like an ETH Denver talk or something like that, and you said that like something like an English auction or that could be possible using the zones. And
So I should, this is actually another advanced technique that we haven't really touched on that you reminded me of. And that is every item, you can specify a start amount and an end amount. So when you do that, it will look at the start time and the end time on that particular order. And then it does a linear interpolation, and we'll just pick out, okay, here's the current amount based on where we are along the timeline for the order. So oftentimes, like when you talk about a Dutch auction, or a reverse Dutch auction, what that really is getting at is it's a sum listing where the price is going down over time, right? Or the price is going up over time. It's not necessarily an auction per se. Now, auctions, there's a couple different ways to run them, and it really depends on what you're trying to optimize for and what your trust model is. Oftentimes, what it really comes down to is like, I have a reserve price, and I want that reserve price to be met, and I want that reserve price to be secret too, right? So, like one way to handle an auction, assuming you have an auctioneer that is someone you trust, is you set the runner of the auction as the zone on your order. Zones, generally the way that we would think of them is that when you have a restricted order, that zone, you're going to call it and say, is this a valid order? If it is, then it'll give back a magic value saying, this is good, go ahead. But another way you can do it is that that zone can actually call Seaport. If they call Seaport, that's also them. If they're the ones that are fulfilling the order, that's also them giving explicit approval per se, right? They're message sender. So you can basically sign a listing that here's my reserve price. That's the consideration item to me. I'm going to give that to this auctioneer, whatever, the marketplace. They're going to keep the order secret, and then they have to be the one to fulfill it, right? It's a restricted order, and they'll apply a tip on that based on the difference between the reserve price and the actual price. There are also constructions where you can do stuff like the commit reveal pattern for hiding the reserve price. You generally have to bond up front. I mean, it gets complicated depending on whether you're optimizing for the privacy of the person that's trying to auction the item, or if you're trying to optimize for protecting the bidders. You know, if you don't want the person running the auction to pull out of the auction and cancel it and yoink their assets or something, their items. There's a number of different variables to control for, but that's one thing that I think would be really cool to see more work on, is leveraging zones to run different kinds of auctions. Yeah. All right, that's time. Thank you all for coming, and can't wait to see what you build.